Hi everyone, welcome to GoClasses. In this session, we are going to discuss propositional logic complete summary. Let me tell you that this complete summary of propositional logic, this is enough if you did not study propositional logic so far. After this complete summary of propositional logic, you can solve each and every GATE previous exam question, GATE previous year question, each and every PYQ you can solve after this propositional logic complete summary is over. Okay, now let's start. So in mathematical logic, we study two type of logic. One is propositional logic, another is first order logic. In this session, we will study propositional logic. Then in the future lectures, we will see first order logic also. Okay. So now in this lecture, we are going to see the complete summary of propositional logic. Let's start. So what is this propositional logic? This is simplest type of logic. Let me tell you, this is actually very easy type of logic. In digital logic, if you have studied Boolean algebra, then this propositional logic, this is similar to Boolean algebra. Okay, so this is simplest type of logic. This is a world of true comma false. Means in this propositional logic, everything is either true or false. If something is not true, then it is false. If something is not false, then it is true. Means everything, every statement, every variable, everything is either true or false. So basically, this is a world of true comma false. Okay, now let's see the first concept. What is proposition? In propositional logic, you might be thinking what this proposition means. So let's see this proposition. What is the definition of proposition? So let me tell you, proposition is just a statement which is true or false. I told you that propositional logic, this is a world of true comma false. Every statement, every variable, everything is true or false. Okay, so what is the definition of proposition? This is a statement which is true or false. That's it. Okay, so let's see what is a proposition. Proposition is a declarative statement which is either true or false, but not both. Means it is either true or it is false. That's it. Okay, so what is a declarative statement? Declarative statement simply means it declares a fact, either a false fact or a true fact. Okay, so you can see a proposition is a statement which is either true or false. Remember, proposition is also called statement. So another name for proposition, that is statement. Okay, so these two things are same. Proposition, statement, these two things are same. For example, you can see these are the propositions. For example, you can see this 3 plus 2 equal to 4. You know that this is a declarative statement. Okay, this is a fact, this is a false fact. It is false, but it is a proposition. Remember, a proposition is either true or false. Okay, so you can see this 3 plus 2 equal to 4. Okay, the truth value of this statement, what is the truth value of this statement? That is false, right? Okay, so that is false. So it is actually false, but this is a proposition. Okay, similarly, you can see this statement 6 less than 24. This is true. This is also proposition. Remember, this third statement, this is also proposition. This fourth statement, this is also proposition. You can see this second statement, triangles have four vertices. This is a false fact. Yes or no? Okay, but this is a proposition, because remember, proposition is either true or it is false. Okay, you can see tomorrow is my birthday. This is also a proposition, because this is a declarative statement. It declares a fact. This statement is declaring a fact. What is the fact? That tomorrow is my birthday. So this is a declarative statement. Okay, and you can see for anyone, okay, if you fix a person at any particular point of time, you can see this will be either true or false. Yes or no? Look at this statement, statement number 5. Okay, if I am speaking this statement, okay, let's assume I am speaking this statement right now, then you can see for me at this moment this statement is false. Yes or no? So this is a declarative statement. Okay, and you can see for me at this moment this is false. Okay, so you can see this is also a proposition. Similarly, this rose is white. This is also a proposition. Okay, so if you fix the rows, okay, on any fix, you fix a day, you fix a place, you fix a rows. Okay, basically you fix the context. You fix the context, then you can see this is a declarative statement. It is declarative. It is declaring a fact. What is the fact? That this rose is white. Okay, either it is true or it is false. It cannot be both. Yes or no? Okay, in any situation, in any given situation, for any fixed rows, tell me, can it be both true and false? No, it cannot be. Yes or no? Either it will be true or it will be or it will be false. So very simple, these are the propositions. Okay, I hope this point is clear. What is a proposition? Proposition is a declarative statement which is true or false. Okay, now let's see what is not a proposition. which statement, which sentence is not a proposition? So let me tell you, like a question. Tell me, this is a question. Did you go to Jane's party? So tell me, this question, is this a declarative statement? No, this is not a declarative statement. This is a question. This is not true or false, yes or no. Okay, we cannot say that it is true or false, we cannot say. Okay, so remember, a question is not a proposition. Similarly, demand is not a proposition. Exclamation statement is not a proposition. Very simple point. For example, keep off the grass. Okay, this is a imperative statement. Next, long live the queen. So this is also imperative statement. Don't say that. This is a command. So you can see command, question, exclamations, these type of sentences, these are not propositions. Okay, I hope this point is clear. So what is not a proposition? Which type of sentences are not a proposition? So not a proposition, for example, question, interrogative sentence, yes or no. In English we call it, this sentence we call it interrogative sentence, right? Okay, so you can see, so remember, a question is not a proposition. For example, imperative sentence, that is not a proposition. Okay, exclamation sentence, that is not a proposition. Okay, command is not a proposition. Like this is a command, don't say that. Okay, so command is not a proposition. So these type of sentences, they are not proposition. Okay, so very simple definition. For example, you can see, fly you fools, this is a command, yes or no. Fly you fools, this is a command. Command cannot be true or false, so command is not a proposition. So remember, this is not a proposition. Next, you can see, why humans sit like this. So this is a question. Question is not a proposition. Question cannot be true or false, so I can say question is not a proposition. Very simple. So finally, this is the conclusion, that proposition. What is proposition? This is a statement which is true or false. That's it. Okay, so very simple point. Now, remember, command and questions, they are not propositions. Now let's move on. Now we have seen what is a proposition. So proposition is a declarative statement which is true or false. That's it. Very simple. Now let's see propositional variable. Okay, now this is the next topic that we need to study, that is propositional variable. You can also call it Boolean variable. These two things are same. Propositional variable, Boolean variable, these two things are same. Okay. So now let's see what is this propositional variable. The definition is very simple. Each proposition will be represented by a propositional variable. Okay. For example, you can see this is a proposition. The sun is shining. This is a proposition. Yes or no? Either this is true or this is false. So the sun is shining. This is a proposition. Now I can represent this proposition using the variable a. So this variable a, this is propositional variable. Similarly, for example, elephants are heavy. This is a proposition. Okay, this is either true or false. So this is a proposition. I can represent this proposition using this variable d. So this variable d, this is propositional variable. So remember, propositional variable, this is also called Boolean variable. These two things are same. And what is this propositional variable? This is very simple. Every proposition is represented by propositional variable. Or I can say that every propositional variable represents a proposition. Okay, for example, you can see this propositional variable C, this represents proposition cats are free. Okay, cats are free. Next, you can see this variable B, this represents this proposition, I feel happy. Okay, so very simple. I hope this point is clear. So remember, proposition variable, they represent propositions. Very simple definition. You can see this. So what is a propositional variable? This is a variable which represents propositions. For example, you can see this variable P. This is a propositional variable and this represents the proposition today is Friday. So you can see this proposition is represented by this propositional variable. Okay. And what is a truth value? You can see either this will be true or this will be false. That is called truth value. Okay. So remember, truth value, true is also a truth value, false is also a truth value. Okay, so very simple. For example, you can see this proposition, either this will be true or this will be false. Okay, and both are called truth values. Now let's move on. Now let me tell you a very important note, that is, in propositional logic we are not interested in English statements. We are only interested in propositional variables. Is this point clear? We are not interested in English statements. We don't care about English statements. We are only interested in propositional variables. We will only deal with propositional variables. Is this clear? So remember, when you study propositional logic, then don't worry about English statements. Okay, do not worry about English statement. For example, Now you might be thinking, sir, today is Friday. You might be thinking, sir, this statement, like on Monday this will be false, on Friday this will be true, yes or no? On Yes or no? On Saturday this will be false, on Friday this will be true. Okay, so let me tell you, we don't care. Let me tell you, we do not care. We do not care about English statements. We only care about propositional variable. I hope this point is clear. Okay, so remember this statement, we are not interested in this statement. Okay, we are not interested in English statement. We are only interested in propositional variable. Okay, so we will only deal with propositional variable. I hope this point is clear. Okay, so remember one more thing, that you might be thinking, sir, is this proposition? On Monday, this is false. On Friday, this is true. Is this proposition? So let me tell you, yes, because you fix a context. Okay, in any fixed context. For example, okay, let's assume you are speaking this sentence on Monday. Then you can see this is a false. Okay, tell me one thing. On any particular day, is it possible this is true as well as false? Is it possible that it is both true and false on a particular day? No. Yes or no? On a particular day, this will be either true or this will be false. It will not be both. So remember the definition of proposition. What is that? Definition of proposition says that proposition is a statement which is true or false, but not both. Okay, you can see on a particular day, this is not both. Okay, whatever day you fix, if you fix Monday, if you speak this statement on Monday, then this statement is false. Yes or no? So, very simple point. So, this is a proposition, and this is represented by this propositional variable P. Now, again, I'm telling you that in propositional logic, we are not interested in English statements. We do not care about English statements. We only care about propositional variables. Okay. So, very simple point. And let me tell you, we will interchangeably use these words. Okay. We will use these words interchangeably. Proposition and propositional variable. These two words we will interchangeably use, because every proposition variable that represents a proposition, or I can say every proposition is represented by a propositional variable. So remember these two words, we will use interchangeably. Okay, so finally, what the conclusion so far? Let me tell you, so far the conclusion is this. So far the conclusion is this, that we are only interested in propositional variables. Okay, we are only interested in propositional variables. So far, this is the conclusion. So if you have proposition variables, for example, let's assume P is a proposition variable, Q, R, okay, these are proposition variable. Then remember, every proposition variable is either true or it is false, but not both. Okay, is this clear? Every proposition variable, every variable is either true or false. That's it. For example, this variable Q, this is also either it is true or it is false, but not both. Okay, so very simple point. And tell me, if something is not true, if something is not true, then it is false. Yes or no? If something is not true, then it is false. And if something is not false, then it is true. Okay, because propositional logic, that is a world of true comma false. Everything is either true or false. Every variable is true or false. If something is not true, then it is false. If something is not false, then it is true. Okay, so this is the simple point. You can read this. Okay, the crucial point, read this. The crucial point, the most important point is that a proposition is true or false. This is the most important point. Okay, now let's move on. Now let's see logical connectives. This is our next topic, logical connectives. Okay, so let me tell you that these are the standard logical connectives that we need to study. You can call them operators or you can call them connectives. So we need to study these logical connectives: negation, not, and, or, exclusive, or, implication, by implication, and, nor. So these are the standard logical connectives we need to study. We need to study what is their behavior. Okay, what is their behavior? So that is what we need to study. Now let me tell you that why we use these logical connectives. So this is very simple, that new propositions means new statements can be created from the existing statements with the help of logical connectives. Okay, with the help of these logical connectives, we can create new statements, new propositions we can create. Okay, let me give you example. For example, consider this statement and consider this statement. So we have statement A, that is, this book is interesting. Another statement B, that is, I'm staying at home. So we have two propositions. Now what we can do, with help of logical connectives, we can create a new proposition. Okay, with the help of a logical connective, we can create a new statement. Is this clear? Very simple. So remember, this logical connective we need to study. You can see that this statement A, statement B we have. Now I can create a new statement. This new statement I can create with the help of logical connective and. Okay, you can see this is another statement I created. Okay, with the help of not. So another statement I created with help of not. Okay, you can see another statement I created with help of or. Okay, you can see another statement I created with help of or but not both. Okay, you can see another statement I created with help of if then. Okay, very simple point. So remember that new proposition, new statements can be created with help of existing proposition. Okay, from the existing propositions with help of logical connective. So very simple definition. If someone asks you what is a logical connective, then what you can say? Logical connective is a way to create new propositions from existing propositions. Okay, so this is the idea. Now let's move on. Now, one by one, we will study all the logical connectives. Let's study the first connective, that is negation, or I can say not. Okay, so let's study this. Consider this statement. This is your proposition. This book is interesting. This is our proposition, and this proposition is represented by this propositional variable p. Okay, so you can see this p represents this statement. Now, what is the negation of this proposition? Tell me. This book is interesting. What is the negation of this proposition? That is very simple. That will be this book is not interesting. Yes or no? So the negation will be this book is not interesting. The same statement I can also say it is not the case that this book is interesting. These two things are same, remember. Okay, so very simple point. Remember, if you have this statement, this book is interesting, then the negation, this is the negation of p. Okay, so remember, this is a negation of p. This is negation of p, and this is the symbol for negation. This is the negation symbol. So very simple point. And remember, I can also say like this, that it is not the case that this book is interesting. This is also negation of p. Okay, so remember negation of p, either you can read like this or you can read like this. Both are same. Okay, very simple point. Now, so let me tell you that if you have a proposition p, if you have a proposition p, let's assume you have a proposition p, then what is negation? Let's see the negation operation. Okay, you can also call it not. Okay, and let me tell you about the symbol. Let me tell you the symbol. The symbol is either you can use this symbol, okay, or you can use this symbol, or you can use this symbol, or you can use this symbol. Okay, so these are different symbols for negation. Okay, you can use any of them. So remember, if you have a proposition p, then what will be negation p? The negation p will be, it is not the case that p. Okay, how to read this? This is very simple. You can read like this, that it is not the case that p. It is not the case. It is not the case that, and then you can write p. Okay, very simple. I hope this point is clear. Remember one thing, that this is same as this. Okay, this is same as p bar, and this is same as p dash. Okay, so all these are different symbols for negation. Okay, very simple point. So if you have a proposition p, then what is negation p? Negation p means it is not the case that p. This is how you will read negation p. Okay, very simple. Now let's see the truth table of negation p, or I can say let's see the behavior of negation p. The behavior of negation p is like this. If p is true, then what will be the value? What will be the truth value of negation p? Let's see the behavior of negation p. Remember, if p is true, then negation p will be false. If p is false, then negation p will be true. So this is called truth value. This is called truth table. This is called truth table of negation p. Okay, is this clear? This is called truth table of negation p. Let me tell you what is a truth table. Basically, truth table gives us what is the definition of negation p, or I can say what is the behavior of negation p. Okay, so very simple. This is called truth table of negation p. Okay, this is the behavior of negation p, that if p is true, then negation p will be false. If p is false, then negation p will be true. Okay, now read this. This book is interesting. This is our statement p. Then what are different English interpretations of negation p? Okay, we have already seen these two. the book is not interesting. We have also seen it is not the case that book is interesting. So these two we have already seen, but there are other English interpretations also. So remember, if you have a statement P, this is your statement P, then what are different English interpretations? Okay, means how to read this negation P in English. Either you can read like this book is not interesting, or you can read like this, it is not the case that this book is interesting, or you can read like this, it is not true that this book is interesting, or you can read like this, it is false that this book is interesting, or you can read like this book is interesting is false. Okay, tell me, is this understood? Let me know. So remember, all these statements are same. All these are different English interpretations of negation P. Okay, this negation P, you can read any of these way in English. I hope this point is clear. Let me know. Let's see this. This is our English statement. 2 is a prime number. Now, these are various English interpretations of negation P. Okay, so this is our statement P. Then what will be negation P? What is the negation of this statement? That will be 2 is not a prime number. Either you can read like this, or you can read like this. It is not the case that 2 is prime number. Or you can say it is not true that 2 is prime number. Or you can say it is false that 2 is prime number. Or you can say 2 is prime number is false. Okay, so these are different ways of reading negation P. Okay, this symbol, remember this symbol you can read in English in many different ways. I hope this point is clear. Okay, let's move on now. So this is the conclusion. If you have a proposition P, then what are different English interpretations of negation P? These are the English interpretations. You can say not P, or you can say it is not the case that P, or you can say it is not true that P, or you can say it is false that P, or you can say P is false. Okay, so very simple point. Now let's move on. For example, consider this statement: Michael's PC runs Linux. Then what is the negation? Find the negation of this proposition. That is very simple. Michael's PC does not run Linux. Yes or no? So either you can write like this, or you can write like this. It is not the case that Michael's PC runs Linux. Okay, very simple. So let's move on now. Now let's see the next logical connective, that is and comma or. Okay, let me tell you, this and is called conjunction and this or is called disjunction. Okay, so these names are also very important, that and is called conjunction and or is called disjunction. Now these are actually very intuitive. Okay, this and comma or, they are very intuitive. Tell me, if I give you two statements, then when you will use this and? We use this and when we want to say that both statements are true. Yes or no? If you have two statements, then when do we use this logical connective? We use this logical connective and when we want to say that both statements are true. And when do we use this connective? We use or when we want to say that at least one of them is true. Okay, we want to say at least one of them is true. So very simple, these are very intuitive logical connectives. Okay, we use this connective when we want to say that both statements are true. We use this connective when we want to say that at least one of them is true. Okay, so let's see one by one. So for example, if you have this statement, this book is interesting, and you have another statement Q, that is I am staying at home, then you can see, you can use this connective and you can use this connective or. Okay, so using this connective you can create a new statement. Similarly, using this connective you can create a new statement. Okay, very simple. Now tell me, when we use and, then basically what we want to say? When we use and, we want to say that both the statements are true. Yes or no? So you have two statement. When do we use the connective and? We use the connective and when we want to say that both of them are true. And when we use this connective or, we use this connective or when we want to say that at least one of them is true. Either this is true or this is true or both are true. Okay, so let's see the behavior of and. First we will see the behavior of and, conjunction. Conjunction, another name for conjunction is and. Okay, and let me tell you the symbol first of all. What is the symbol for and? Symbol is, this is the symbol. Okay, this is the symbol. Okay, so either you can use this symbol P and Q. Remember, you can also use this symbol P dot Q, or you can directly write PQ. Okay, or you can directly write PQ, but this is the standard symbol for and. So this is the symbol for and. Okay, very simple. But remember, P and Q you can directly write as P dot Q, or you can write PQ. All these things are same. Okay. Now, when you have this statement, for example, if I give you this expression, then what it means in English, how to read this? This is mathematical formula. Yes or no? This is mathematical expression. In English, how to read this? In English, you can read like this. You can simply say P and Q. That's it. Okay. Basically, we want to say that P is true and Q is true. Means both the statements are true. Okay. Now let's see the truth table. Okay. Let's see the behavior of this conjunction. Let's see the truth table. So you can see if you have PQ, okay, then what is the behavior of P and Q? What is the behavior of P and Q? Now you tell me one thing. P is a proposition, Q is a proposition, right? Okay, P is a proposition, Q is a proposition. So either P is true or false. P can be true or false. Yes or no? Either P is true or P is false. Similarly, Q is true or Q is false. Yes or no? Either Q is true or Q is false. Very simple. So tell me how many truth value combinations are possible? For P comma Q, how many combinations are possible? You can see the truth value of P is one of them. The truth value of P is either this or this. Similarly, the truth value of Q is one of them. Okay, so how many truth value combinations are possible? Four combinations are possible. Okay, for example, maybe both are false. Okay, maybe this is false, this is true, maybe P is true, Q is false, or maybe both are true. Okay, so you can see there are four truth value combinations are possible. Now, let's see the behavior of this conjunction in all these cases. So you can very easily see that this will be true when both are true. Yes or no? This and, you can see and simply means that this and will be true. This will be true when both P comma Q are true. So you can see only in this case, you can see only in this case, this P and Q will be true. Okay, yes or no? If at least one of them is false, if P is false or Q is false, if any of them is false, then in that case, you can see this and will become false. Okay, so very simple point. I hope this point is clear. So this is the only situation where P and Q is true. Okay, P and Q is true if and only if both are true. Okay, means P and Q is true only in the situation when P and Q both are true. Very simple. So this is our conjunction operation. I hope this point is clear. Okay, so we have seen, for example, if this is your statement P, this is your statement Q, then what is P and Q? That is very simple. Okay, how to read this in English? We read this as P and Q. This symbol means and. Okay, so I can say it will be P and Q. This book is interesting and I'm staying at home. Okay, so this is the truth table. You can easily see. This is the truth table of P and Q. Okay, let's move on now. Now let's see disjunction. Now let's see disjunction. It is also called or. It is also called inclusive or. These are different names for disjunction. Okay, these are different names. You can call it or, you can call it inclusive or. So first of all, you tell me the symbol. What are the symbol? The symbol is this. Okay, very simple. This is the standard symbol. But let me tell you that you can use this symbol or you can use this symbol plus. Okay, but actually, okay, don't call it plus. Don't call it plus. You call it or. Okay, so remember, when I write this, then I will call it or. So either you can use this symbol P or Q. This symbol also means or. Okay, this symbol means or, so you can call it P or Q. Okay, you can call it P or Q. So these are the symbols for P or Q. Okay, now the second thing, see, this is your mathematical expression. In mathematics, if you write like this, then in English, how to read this? In English, very easily you can read this will be P or Q. That's it. Okay, so let me tell you one more thing. Either you can read like this is also correct, or you can read like this, P or Q or both are correct. Okay, so when you say P or Q, then also this means, and when you say P or Q or both, then also this means. So remember, both are correct. This is also correct, this is also correct, because I told you disjunction, another name is or, another name is inclusive or. Means when both P comma Q are true, when both are true, then also this is true. Okay, remember, when you use this word or, this word or we use when we want to say that at least one of them is true. Either P is true or Q is true or both are true. Okay, so very simple. When at least one of them is true, then this will be true. Okay, so remember, if you want to read this in English, then either you can read like this, P or Q, or you can read like this, P or Q, or both. Both are correct. Okay, this and this, they are same. I hope this point is clear. Okay, so very simple. Now let me tell you the truth table. Okay, now let's see the behavior of or. So again, very simple. These are the proposition variable P comma Q. Now what is P or Q truth table? Okay, what are the behavior? So again, you can notice, remember, P is a truth, P is a proposition variable, so either it is true or it is false. Okay, similarly, Q is either true or Q is false, because every propositional variable, every variable in propositional logic is either true or false. Okay, so the truth value of P is one of them, and the truth value of Q is one of them. So how many truth value combinations are possible? Four combinations are possible. You can see either they are both false false, or P is false, Q is true, or P is true, Q is false. Okay, or both are true true. Very simple. Now tell me in which case this will be true. This is or P or Q. This will be true when at least one of them is true. Okay, this P or Q, this will be true when at least one of them is true. If Q is true, then also P or Q will be true. If P is true, then also P or Q will be true. If both are true, then also P or Q will be true. Okay, but when both are false, when P comma Q both are false, then this P or Q will be false. So this is the only situation. Remember, this is the only situation where P or Q is false. So P or Q, this is false when both P comma Q are false. Okay, if at least one of them is true, then P or Q will be true. Okay, so this is the behavior of P or Q. I hope this point is clear. So you can see this is mathematical expression P or Q. In English, how to read this? This is very simple, P or Q. That's it. Very simple point. Now let's move on. So this is the truth table of P or Q. You can see that P or Q, that is false only in this case. Only in this case, P or Q is false. In all other cases, P or Q is a true. Okay. So very simple. Now let me tell you that this or, this is also called inclusive or. Okay, so again I am telling you that if you have this statement P or Q, then how to write this? You will write like this, P or Q. Okay, and similarly if you have this statement P or Q or both, okay, this is also same as P or Q. So these are different ways of writing P or Q. You can write like this, P or Q, or you can write like this, P or Q, or both are same. Okay, both are same. Now let's move on. Now, let me tell you one more thing, that in propositional logic, these English words, they are same as and. Okay, in propositional logic, in logic, remember, these all these different English words, they have the same meaning as and. Okay, so remember, but is same as and, though is same as and, even though is same as and, however is same as and, yet is same as and, nonetheless, nevertheless, moreover, all these words, they will translate. Okay, they will translate as and. So you can see the English words like even though, however, but, yet, all are translated, remember, all are translated to and in propositional logic. Okay, is this point clear? What I want to say, I want to say that if you have this statement, for example, P but Q, P but Q, then how to write this? Very simple, this will be your P and Q. Okay, for example, if you want to say P yet Q, okay, that is also same as P and Q. Okay, is this point clear? If you want to say that P comma Q, then also that is same as P and Q. Okay, this comma, okay, let me write it, this comma also means and. Okay, and remember, this is very intuitive. Tell me, when you write some statement and comma some statement, then that means or that means and. Tell me, in your real life, in your daily life, if you write something, then comma something, then comma something, then what do you want to say? Do you want to say and, or do you want to say or? You want to say and, yes or no? So comma means and. Do you agree with me? Yes or no? So remember, in real life, in daily life, this comma we use for and. Similarly, this but also translates to and, this though also translates to and. I hope this point is clear. Let me know. For example, if you have this statement like P however Q, that is also same as P and Q. Okay, and if you have P and Q, that is also same as P and Q. Okay, I hope all these points are clear. Okay, let's move on. Let me tell you, this is not important actually, but this is a simple point, that all these different English words, okay, they will translate as and. Okay, now let's move on. Now let's see the next logical connective, that is exclusive or. In short, you can call it XOR. Okay, exclusive or you can call it XOR, or you can call it XOR. So let's see what is this connective. So let's see exclusive or. In short, we call it XOR. Okay, you can also call it like XOR, both are fine. And what are the symbol? First of all, let me tell you about the symbol. So the symbol is like this. This is the symbol. Okay, this is the symbol. And some people, they use this symbol also. Both are fine. Okay, remember, exclusive or. So these are the symbols. This is very frequently used. Okay, but some people they use like this also. So this is the symbol. So I can say, for example, this means, okay, this is same as basically this. Okay, they both are the symbols for actually exclusive or. Okay, now let's see what is the meaning of this symbol. What is the meaning of this symbol when you write like this? See, this is a mathematical expression. Okay, this is mathematics, right? Now in English, how to read this? When I give you this, then how to read in English? Very simple, that is very simple. So it will be P or Q, but not both. But not both. So this is how we read it. Okay, remember, we read like this: P or Q, but not both. So that is the reason this is called exclusive or. This is called exclusive or, means basically when both are true, that possibility we remove. Okay, so remember, when I say P XOR Q, that means this is true when either P is true or Q is true, but not both. If both are true, then this will be false. Okay, so this is the idea. I hope this point is clear. So remember, if you have this, then how to read in English? In English, we read like this: P or Q, but not both. Okay, is this point clear? Like this, we read P or Q, but not both. So this is your P XOR Q. Very simple. Now let's see the truth table. Let's see the behavior of P XOR Q. So you can see this is P, this is Q. These are the two propositional variables. Now, how many truth value combinations? Four combinations are possible. Maybe both are false. P is false, Q is true. Maybe P is true, Q is false. Maybe both are true. So these are the truth value combinations. Now, tell me what will be the behavior of P XOR Q. You can easily read this. What this P XOR Q says, this says that P is true or Q is true, but not both. Means P is true or Q is true, but not both. Means exactly one of them is true. Means exactly one of them is true. Exactly one of them is true. Here, this P XOR Q will be true. Okay. Here also P XOR Q will be true. But you can see, but not both. If both P comma Q are true, then P XOR Q will be false. Okay. Here also it will be false. So this is the truth table of P XOR Q. Okay. I hope this point is clear. So very simple point. Again, I'm telling you that this P XOR Q, this P XOR Q, this simply means P or Q, but not both. But not both. So that I can also say that, okay, this simply means exactly one of them is true. Exactly one of them. Exactly one of them is a true. Is this point clear? Not more than one, not less than one. Okay, exactly one of them is true. Not more than one, not less than one. Exactly one of them is true. Okay, so this is your P XOR Q. Very simple. I hope this point is clear. Okay, so I can also say like this: if you have PQ, then tell me this P XOR Q, basically this will be true. When this will be true, this P XOR Q, this will be true basically when they are different. Yes or no? Like when they are different, when P comma Q are different, then this will be true. Yes or no? When P comma Q are different, then this will be true. Okay, and when they are same, then this will be false. Okay, so you can also think like this. You can also think like this, that P XOR Q is true when P is not equal to Q. Okay, when P is not equal to Q, then P XOR Q is true. Okay, but very simple point. Remember that this P XOR Q, this simply means P or Q, but not both. This is how you read this. And what this means? This means exactly one of them is true. Not more than one, not less than one. Exactly one of them must be true. And this is the truth table. So you can see. So this is the symbol P XOR Q. Okay, so either P or Q, but not both. Okay, very simple. Now, this is the truth table. Let's move on now. For example, consider this statement, either P or Q. Tell me how to translate this. Let me tell you a note here. Let me tell you note here. If you have this statement, either P or Q, either P or Q, how to translate this? Very simple. This is simple, your P or Q. Okay, this is same as P or Q. But remember, if you say either P or Q, but not both, either P or Q, but not both. Now, how to translate? Now, this will be exclusive or. Is this point clear? Okay. So remember, P or Q, that is same as P or Q. Either P or Q, that is also P or Q. But if you say or but not both, that is your exclusive or. Okay, you can see this. This is a screenshot from a top university. You can see this is statement P, the butler did it. This is statement Q, the cook did it. Now you can see what this P or Q. This is either the butler or the cook did it. Okay, very simple. You can see this next statement P XOR Q. This means either P, C, either P or Q, but not both. Okay, is this clear? So this means either P or Q, but not both. Very simple. Okay, let's move on. Now let's see the next logical connective, that is NAND NOR. These logical connectives, let's see. Okay, these are actually very simple. What is NAND? What is NOR? See, NAND simply means the name itself is telling you. The name itself is telling you not of and, negation of and, negation of and, or I can say not of and. The name itself is telling you this is not of and. Now let me tell you what is the symbol. See, the symbol is up arrow. The symbol is up arrow. Okay, so for example, if you have this up arrow, okay, you can also write it P NAND Q. You can also call it P NAND Q. And basically what this means negation of and. Means first you do and, then you do negation, then you do negation. Is this point clear? So this is your NAND. NAND means negation of and. Very simple. So now you can create the truth table. So tell me what will be the truth table of NAND. P Q, P NAND Q. The truth table is very simple. You can see in all cases, for every truth value combination of PQ, tell me, for every truth value combination of PQ, what will happen? Very simple, negation of and. Just do negation of and. Yes or no? In this case, and will be false. So negation of and will be true. In this case, and will be false. So negation of and will be true. In this case, and will be false. So negation of and will be true. In this case, and will be true. So negation of and will be false. Okay, is this clear? So this is the truth table of NAND. Okay, let me know. Very simple. Now tell me about NOR. Now tell me about NOR. The next is NOR. The name itself is telling you. Again, the name itself is telling you this is negation of or. Okay, this is negation of or. So what is NOR? You can see NOR is negation of or. So the symbol, what is the symbol? Symbol is down arrow. This symbol is down arrow. So P NOR Q. That means that is negation of or. Okay, negation of or. First you do or, then you do negation. Okay, so what will be the truth table? The truth table will be very simple. Remember, for this combination, or will be false. So negation will be true. For this combination, or will be true. So negation will be false. Yes or no? For these combinations, or will be true. So negation will be false. So this is the truth table of NOR. I hope all these points are clear. So we have seen NAND NOR. Okay, we have seen P NAND Q, P NOR Q. These things we have seen. NAND means negation of and. NOR means negation of or. Very simple. Okay, let's move on now. So far, what we have seen negation, we have seen conjunction, we have seen disjunction. Okay, these operators we have seen. Now let's move on. We also have seen exclusive or, we have seen NAND NOR. Okay. Now let's see logical connective. The next logical connective, that is implication. And this is most important. Let me tell you that so far all the connectives that we have seen, those were actually very easy, very intuitive. Okay. But let me tell you this implication, this is the most important logical connective. Okay. So we will give a lot of time to implication. We will discuss all about this implication. Now let's start. What is this implication? What is this? Implication. This is most important logical connective. You can say implication or you can say conditional, both are fine. Okay, you can also call it conditional statement. Okay, so let me first tell you about the symbol. What is the symbol? The symbol is this is the implication symbol. Okay, so this is the symbol. Now let me tell you that when we write p implication, this symbol means implication, right? Okay, this symbol means implication. This is the symbol of implication. Okay, because our next logical connective, that is implication. So this is the symbol for implication. Now how to read this in English? How to read this in English? This is very simple. This simply means P implies Q. Okay, either you can read like this or you can read like this. If P, then Q. Okay, what this means, let me tell you what this says. This says that if P is true, then Q is true. Okay, means if P, then Q. If P happens, then Q happens. So this is how you read this in English. You can say P implies Q. This is also correct. You can say if P, then Q. This is also correct. Or you can simply say if P, comma Q. Okay, means if P happens, then Q happens. So all these are correct. Okay, very simple. Now let's see. For example, consider this English statement: if today is Sunday, then I am happy. Okay, so in the propositional logic, how to write this? See, this is the English statement. Now you can easily see today is Sunday. Let's represent this by variable s. Okay, by proposition variable s. And this I am happy. This proposition I am representing by proposition variable h. Okay, now what I have? I have if s, then h. Okay, how to write this? If s, then h. How to write this? This is very simple. S implies h. Okay, this is how to write. S implies h. Very simple. So remember this implication, this arrow. Okay, you can see this arrow. This means implication. And how to read this in English? This is very simple. P implies Q, or you can say if P, then Q. If P is true, then Q is true. If P happens, then Q happens. Okay, so like this. Now, let me tell you few more things about this P implication Q. Here, let me tell you that first of all, this is called implication statement. You can call it implication statement. This is implication statement. Or you can call it conditional statement. Or you can call it conditional statement. Okay. And in this, whenever you have this P implies Q, whenever you have this P implies Q, then remember this LHS. Okay, this LHSP, this is called hypothesis. This P is called hypothesis, or you can call it antecedent. Okay, these are different names for P, or you can call it antecedent, or you can call it premise. Premise. So this P is called hypothesis, or you can call it antecedent, or you can call it premise. And what this Q is called? This is called consequence. This Q is called consequence, or you can call it conclusion. Okay, very simple. Now we will see the behavior of P implies Q. Okay, a student is asking what is antecedent. See, this is just a name for this P in P implies Q. When you write P implies Q, this P is called antecedent, or you can call it hypothesis, or you can call it premise. So this P is called premise, and this Q is called conclusion or consequence. Okay, these words are not very important, but you should know that this P is called antecedent or premise or hypothesis. These are not very important, let me tell you. Okay, now let's move on. Now let's see the behavior. Okay, so first of all, you can see if this is your statement A, this is your statement B. Now what is A implies B? How to read this? Tell me. When you see this in mathematics, then how to read this? This is very simple. If A, then B. Yes or no? So very simple. If A, A is it is sunny today. If it is sunny today, then B is there will be picnic. Okay, you can see. Similarly, you can see if this is A, this is B, then how to read this? How to read this? This means if A, then B. If A, then B. Okay, very simple. Okay, I hope this point is clear. Now let's move on. Now we will see the behavior. We will see the truth table of implication. Okay, and for that, you tell me the answer to this question. Let's assume you are booking a flight ticket. Okay, and there is a airline Y. For example, maybe Indigo, SpiceJet, okay, some airline is there. Now, this airline makes a claim. This airline says, for example, maybe SpiceJet or maybe Air India. Now you can see they are saying that if you fly with us, then you will get free food. This is an implication statement or not? Tell me. This is an implication statement or not? Yes, if something, then something. Okay, if P, then Q. Okay, now you tell me when this claim will be false. A simple question I'm asking, that when this claim will be false. So this SpiceJet, this airline is saying that if you fly with us, then we will give you free food. Now, when this claim will be false, this claim will be false when this becomes true, when you fly with SpiceJet but they don't give you free food. Do you agree with me? Let's call it P and let's call it Q. The claim will be false when you will say claim is false, claim is false. The claim will be false when you fly with them, when you fly with them, when P is true, okay, and Q is false, and Q is false. Do you agree with me? Tell me, in this situation, what you will say? In this situation, you will say that claim is false. Okay, means claim will, remember, this claim will be false when you fly with them, okay, but they don't give you free food. When P is true and Q is false, then you can say that claim is false. Yes or no? Agree with me? Now tell me one thing. Tell me one thing. If you don't fly with them, then 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 can you say claim is false? If you don't fly with them, then can you say the claim will be false? Now the claim cannot be false. Do you agree with me? Okay, very simple point I'm saying. If you don't fly with SpiceJet, see, SpiceJet is saying that if you fly with SpiceJet, you will get free food. This is what SpiceJet is saying. Let's assume you don't fly with SpiceJet. Now tell me, will you get free food or not? Tell me. Let's assume you don't fly with SpiceJet. Now you tell me, will you get free food or not? Maybe you will, maybe you won't. Yes or no? Maybe Air India will give you free food, or maybe Air India will not give you free food. So I'm saying that if this P is false, then this can be true or false. Yes or no? If this P is false, then this can be true or false. But remember, if this is true, then this must be true. Do you agree with me? According to this claim, according to this claim, if you fly with SpiceJet, then definitely this must be true. Okay, so this is the idea. Remember, this is your P. Okay, let's call it Q. So this is your conditional statement. This is the conditional statement. And this claim, what this claim basically says, this claim, what this claim means, let me tell you. This claim means that if P is true, then Q must be true. If P is true, this is what the claim means. Claim means that if P is true, then Q must be true. Then Q must be true. Okay, but remember, if P is false, then Q can be false or true. Okay, yes or no? If you don't fly with SpiceJet, then maybe you can get free food, or maybe you will not get free food. Maybe Air India can give you free food, or maybe Air India will not give you free food. So I can say if P is false, if P is false, if P is false, then Q can be anything. Then Q can be anything. Then Q can be true or false. Yes or no? Then Q can be true or false. Very simple. Q can be true or false. Q can be true or false. I hope this point is clear. Very simple point. So now I can create the truth table. So this is your, remember, if P then Q. This statement is if P then Q. Okay, how to read this? How to write this? We write like this: P implies Q. P implies Q. Now the truth table. I am writing the truth table now. Okay, so focus here. P, Q. Okay, and this is your P implies Q. You can see there are 4 truth value combinations. Maybe both P comma Q are false. Maybe P is false, Q is true. Maybe P is true, Q is false. Maybe both are true. So these are the 4 truth value combinations. Now you tell me, this P implies Q. This P implies Q. When this will be false? This claim is P implies Q. This claim is P implies Q. This is your claim. Tell me when the claim will be false. Only one way to make the claim false. Only in this case, the claim will be false. Do you agree? Only in this case, claim will be false. When you fly with SpiceJet, means when P is true, but they don't give you free food. Q is false. Okay, when P is true, Q is false. Then in this situation, claim will be false. In all other situations, claim cannot be false. In all other situations, claim cannot be false. Yes or no? Is this clear? Okay, only in this situation, claim will be false. In all other situations, claim cannot be false. Is this point clear? Very simple. So finally, this is the truth table. Okay, and this is very important. Let me tell you, this truth table is very important. I tried to make you understand, but if you did not understand, if you have any doubt, then you should remember this truth table. Okay, so this is the behavior of P implies Q. Let me tell you, this is very important. P implies Q. Okay, the behavior is like this. Remember, this P implies Q, this will be false only in one case. Only in one situation, this P implies Q will be false, and that situation is when P is true, Q is false. Okay, in this situation, this P implies Q will be false. Because see what this means. This says, this P implies Q. This says, if P is true, then Q must be true. Yes or no? If P is true, then Q must be true. But you can see in this situation, when P is true, Q is false. In this situation, this will be false, because this statement says that if P is true, then Q must be true. If P is true, then Q must be true. Okay, in this situation, I can say P implies Q will be true. But remember, if P is false, then Q can be anything. If P is false, then Q can be anything. Then Q can be anything. The claim cannot be false. The claim cannot be false. So this is the truth table. TTFT. Okay, this is the truth table of P implies Q. And you should remember this truth table. This is very important. So you can see the only way to make P implies Q false, the only way to make P implies Q false, that is when P is true, Q is false. This is the only way to make P implies Q false. Okay, very simple. Now let's move on. You can see P is this book is interesting, Q is I am staying at home. Okay, then what is this P implies Q? This means P implies Q, means if P then Q, means if this book is interesting, then I am staying at home. Okay, very simple. So this is your P implies Q. I told you that in this P implies Q, what is this P? This P is called hypothesis or antecedent or premise. This is what this P is called. And what this Q is called? This Q is called conclusion or consequence. Okay, this is your implication statement, or you can call it conditional statement. Conditional statement, implication statement, both are same. Okay, let's move on now. Okay, you can see this is your Stanford slide. See this. This is Stanford. From the Stanford, I have taken this slide. Read this line. Read this from the Stanford. What they are saying? They are saying that you will need to commit this table to memory. We are going to use this a lot. Means you should remember this implication table. This implication behavior you should remember. If you understood, then very good. Okay, I have given you the example. Yes or no? I have already given you the airline example. Okay, so if you understood, then very good. If you did not understand, then you should remember this table. Okay, this I am not saying. You can see Stanford is saying that you should remember this table. So this is very important. Okay, and remember the only way to make implication false, that is a P true, Q false. Okay, now let me tell you that conditional statements are one way. They are one way. Means, for example, consider this conditional statement. This is a conditional statement, right? If something, then something. Okay, if P, then Q. Now remember, the conditional statements are one way. Means if this happens, then definitely this will happen. Okay, but if this does not happen, then this may or may not happen. Okay, so let me write it. For example, let's assume that you are in Delhi. Okay, you are in Delhi. Let's call it, let's represent this with variable D, and let's represent this with variable I. So this proposition I am representing by variable D. This proposition I am representing by variable I. Now, what this statement? This statement is if D, then I. Okay. Now you tell me a simple point. If you are in Delhi, does it mean you are in India? Tell me. Does it mean if you are in Delhi, does it mean you are in India? Yes. But tell me one thing, very important point. So if you are in Delhi, definitely means you are in India. Okay, this is fine. This is fine. But now you tell me, if you are not in Delhi, can I say you are not in India? Tell me, if you are not in Delhi, if you are not in Delhi, can I say you are not in India? Can I say you are not in India? No, I cannot say. No, I cannot say. Yes or no? This is a nonsense. Okay, this is wrong. You may or may not be in India. If you are not in Delhi, maybe you are in Rajasthan, maybe you are in Tamil Nadu, maybe you are in some other state. Yes or no? Maybe you are in Hyderabad. Now you can see that if you are not in Delhi, then maybe you are in Hyderabad. Okay, so you are in India. Or maybe you are in London, then you are not in India. So what I'm saying that if this D is false, remember, if D is true, then this will be true. But if this D is false, if you are not in Delhi, okay, then you may or may not be in India. Yes or no? Then you may or may not be in India. You may be in India, you may not be in India. So remember, conditional statements are one way. Means if this happens, then this will happen. But if this does not happen, then we cannot say anything about this. Okay, is this point clear? Simple, right? Okay, very simple. So remember, conditional statements are one way. So if I give you a conditional statement P implies Q, what this says, what this means, this simply means that if P is true, then Q will be true. This simply means if P is true, then Q will be true. Then Q should be true. Then Q must be true. Okay, then Q must be true. But remember, if P is false, then Q can be anything. Then Q can be true or Q can be false. Okay, then Q can be anything. So, very simple. So, conditional statements are one way. If P is true, then I can say Q will be true. But if P is false, then Q can be anything. Okay. Now let's see. Only one case when P implies Q will become false. Do you agree with me? There is only one case. There is only one case when P implies Q will become false. And what is that case? What is that case? That is when P is true and Q is false. Okay. This is the only case where P implies Q will become false. This is the only one case where P implies Q will become false. Okay. And there are three cases. There are three cases. There are three cases where this P implies Q will become true. What are those three cases? Those three cases are, okay, if P is false, Q is false, or if P is false, Q is true, or if P is true, Q is true. Okay. So in these cases, P implies Q will become true. Very simple. Now let's move on. Okay. Now let's see. Let's see this statement. P implies Q is true when P is false or Q is true. Can I say? Read this statement. I am saying P implies Q, that is true when P is false or Q is true. When P is false or Q is true. Is this true? Is this correct? Is this statement correct? Yes. See, notice. P implies Q is true. Look at where P implies Q is true. Here P implies Q is true. Here P implies Q is true. You can see P implies Q is true when P is false or Q is true. You can see when P is false. Okay, here you can notice P is false, right? Here P is false. And in these situations, you can see P implies Q is true. Yes or no? And here you can notice that, look at this first and third. Look at this first, sorry, second and fourth. Look at this second and fourth. Look at second and fourth. Their Q is true. In both the situations, you can see that P implies Q is true. Yes or no? Okay. So finally, what I am saying, please notice, I am saying that P implies Q is true when P is false or when Q is true. This covers every possibility. Do you agree with me? This covers every possibility. You can see this covers the first two and this covers the second and fourth. Okay. So they cover all the possibilities. I hope all these points are clear. Okay. So very simple point. Finally, this is the conclusion. This is the conclusion that P implies Q when this will be true. This P implies Q. This is true. This is true when P is false or Q is true. Okay. P is false or Q is true. P is false or Q is true. So like this you can write. Okay. Very simple point. Now let's move on now. One more thing. So here you can notice one thing, this P implies Q. So I can also write it like this, P implies Q. Remember, P implies Q is true when this happens. This P implies Q, this is true when this happens. So I can say P implies Q, that is basically same as P is false or Q is true. How to write P is false? How to write P is false? Tell me, if I want to write P is false, how to write that? I want to write P is false. How to write that? Negation P. Yes or no? We have already seen this. Okay, how to write P is false? That is like this. Okay, like this you can write. So very simple point here also, that this P implies Q. This is same as P is false or Q is true. Okay, P is false or Q is true. Means I can say P dash or Q. Is this understood? Please tell me. Is this clear? Let me know. So these two things are same. These two things, they are same. Okay, very simple explanation, very simple idea. So they are same. Okay, so you can see these are the important properties. P implies Q, that is same as P dash or Q. And this is a very important property. This P implies Q, this is actually very important. Very important property. Okay, and remember one thing, this is also P implies Q, this is also P implies Q. Yes or no? This is also P implies Q, here also P implies Q. So these two things are same. Okay, and this is a very important property. So this we will use many times, let me tell you. Okay, so you should remember this property. This is actually very useful property. You should remember this, that alpha implies beta, that is basically same as alpha dash or beta. Okay, alpha dash or beta. Is this clear? Like P implies Q, that is same as P dash or Q. Negation of P or Q. Okay, so this property is actually very important. So remember this property. If you want to prove this property, you can prove using truth table also. Remember this property. This P implies Q. This is same as negation P or Q. Okay, you can prove it. Let's see the proof using the truth table. Okay, let's create the truth table of both of them. This is P, this is Q. Only 4 cases are possible. 4 truth value combinations are possible. So you can see these are the truth value combinations. Now let's see what is the truth table of P implies Q. What is the truth table of P bar or Q? So tell me, what is the truth table of P implies Q? That you already know. This is your favorite TTFT. Only in this case, P implies Q will be false. Okay, next you can see what is the truth table of P bar or Q. This is P bar or Q. Okay, so tell me, for this combination, what will be the truth value of this? When P is false, Q is false, what is the truth value of P bar or Q? That will be true. Okay, in this case also P bar or Q will be true. In this case, P bar or Q will be false. In this case, P bar or Q will be true. So did you notice they have the same truth table? Look at this truth table. Look at this truth table. They are the same. Yes or no? Yes or no? They are the same. So finally, I can say that they are also same. Okay, is this clear? Let me know. Very simple. So this is how you can prove it. So remember, this is a very important property. P implies Q, that means P bar or Q. Alpha implies beta, that means alpha bar or beta. Now, now let's see what is the difference between P implies Q and Q implies P. Are they same? P implies Q, Q implies P. Are they same? No, they are not same. Okay. Remember, when you write P implies Q, what you want to say? You want to say that if P is true, then Q is true. Okay. And when you write Q implies P, what you want to say? You want to say that if Q is true, then P is true. Okay. Actually, they are different. They are different. Let me tell you, you can create the truth table and you can check that they are actually different. This P implies Q and Q implies P, they are different. Tell me, what will be the truth table of P implies Q and what will be the truth table of Q implies P? Remember, this will be false when P is true, Q is false. Yes or no? Remember, this will be false only in this case. Please understand, this will be false only in one case where P is true, Q is false. Okay, so only in this case, this will be false. Okay, right. So I can say here it will be false. In all other cases, it will be true. Now look at this. Look at this. Okay, so in this one, this is the premise, this is the conclusion. Yes or no? Here Q is the hypothesis, P is the conclusion. So you can see Q implies P. This will be false only in one case, when Q is true, P is false. Remember, this is also implication. Q implies P. So remember, this will be false in only one case, where Q is true, P is false. Okay, where Q is true, P is false, means in this case, this will be false. Okay, so in this case, Q will be this Q implies P will be false. Okay, in all other cases, it will be true. Look at the truth table and tell me, are they equivalent? Look at the truth table and tell me, are they same? This is TTFT, this is TFTT. They are different. Yes or no? They are different. So remember, this and this, they are not same. Okay, this and this, they are not same. This P implies Q, Q implies P, they are not same. Very simple. Okay, so very simple point. P implies Q, Q implies P. You can see they are not same. Okay, now let's move on now. Another property, let's see another property, that is P implies Q, that is same as Q bar implies P bar. Okay, this also you can easily prove it. Okay, remember this property says that P implies Q, that is same as Q bar implies P bar. Okay, means this and this, they are same. P implies Q is same as Q bar implies P bar. Okay, again you can easily prove it with the help of truth table. So the truth table of P implies Q, that is here. Okay, let's create the truth table of Q bar implies P bar. Let's create the truth table of Q bar implies P bar. Tell me what will be the truth table. Let's see. Okay, tell me, for this combination, when P false, Q false, for this combination, what is the truth value of this? What will be the truth value of this expression? You can easily see, when P false, Q false, then this is true implies true. True implies true is true. True implies true, that is true. You already know. Okay, true implies true. You already know that is true. Okay. Next, you can see, when P false, Q true, then what this will be? When P false, Q true means P false, Q true. So you can see Q bar is false, P bar is true. False implies true. What is that? False implies true. That is also true. Okay, so here also you will get true. What about the next case? When when P true, Q false, then what will happen here? You can see it will be true implies false. And what is true implies false? You know true implies false, that is false. Okay, you already know true implies false, that is false. So here you will get false. And finally, here you will get true. Okay, so you can see, did you notice they are same? This and this, they are same. So remember, P implies Q, that is same as Q bar implies P bar. Okay, so they are same. So remember this. So P implies Q, this is same as P bar or Q. This is also same as Q bar. Q bar implies P bar. Okay, so these are the properties. This is the first property, this is the second property. P implies Q is same as P bar or Q. Similarly, P implies Q, that is same as Q bar implies P bar. These are the two properties. These are useful, very useful properties. Okay. Now let's see implication continued. Did you notice one thing? We are spending a lot of time in implication. I told you implication is very important. Okay, so that is the reason we are discussing every important point, every concept related to implication. Okay, now the next concept, that is necessary and sufficient conditions. Let's understand what necessary means. Let's understand what sufficient means. These two words, what they mean. Let's understand. Okay, consider this example. Filling the gate exam application form, that is for cracking the gate exam. Tell me, is it necessary or is it sufficient? See this, filling the gate application form, can I say that is sufficient for cracking the gate exam? Remember, sufficient means enough. Sufficient means enough. Sufficient means enough. Okay, and necessary means mandatory. Okay, necessary means mandatory, right? So now you can see, tell me, if you fill the gate application form, can I say that is enough to crack the gate exam? You fill the application form, can I say that is enough? Can I say that is enough to crack the gate exam? No, that is not enough, right? Okay, but that is necessary. If you want to crack the gate exam, then it is necessary that you fill the application form. So very simple point, that it is necessary but not sufficient. Yes or no? So finally, what I can say, I can say that this is the statement I can say. I can say filling gate application form is necessary. Okay, if you fill the gate application form, that is necessary for cracking the gate exam. Now you tell me one more thing. What this statement actually means? Does it mean, does it mean, see, okay, let's see this. Filling the application form, let me call it P. Okay, let me call it P. And crack the gate exam. Crack the gate exam, let me call it Q. Okay, so finally, what is this statement? This statement is like this: P is necessary for Q. Yes or no? This statement is P is necessary for Q. Okay, you can see P means you are filling the application form. This is P. And Q is cracking the gate exam. You are cracking the gate exam. So this statement basically is P is necessary for Q. Tell me one thing. What this means? Does it mean P implies Q, or does it mean negation P implies negation Q? Tell me. Does it mean P implies Q, or does it mean not P implies not Q? If P happens, then Q happens. Can I say? Can I say if P happens, then Q happens? If you fill the application form, then can I say you will crack the gate exam? Can I say if you fill the application form, then you will crack the gate exam? No, no, this is not correct. Yes or no, this is not correct. But can I say that if you don't fill the application form, if you don't fill the application form, then you cannot crack the gate exam? Yes, this is correct. Yes or no, this is a correct. Is this clear? So very simple point, remember. Let's see another example. With this example, you will understand. Air is for being alive. Tell me, air, or I can say oxygen, that is necessary or that is sufficient for being alive? Can I say air is sufficient? Sufficient means enough. Can I say air is enough to keep you alive? Can I say air is enough to keep you alive? No, you also need water. You also need food. At least water you need. Yes or no? You need water, you need food, you need sleep. A lot of things you need. Okay, so very simple point. Air, can I say that is necessary? Yes, air is necessary, right? Air, definitely air is necessary, but air is not sufficient. Air is not sufficient, but air is necessary. Okay, now see this. Air is necessary for being alive. Okay, so what this means? Does it mean air implies alive, or does it mean not air implies not alive? What this statement means? This statement, what it means? See, this statement is true. You know this statement is true. Air is necessary for being alive. This statement is true. Very good. Now, what this statement means? Does it mean air implies alive, or does it mean not air implies not alive? Okay, very good. This is what it means, not this. Okay, remember, air is necessary for being alive means if there is no air, then you are not alive. Okay, so final conclusion. Let me give you the final conclusion. Final conclusion is like this. This is the conclusion, that this statement, P is necessary for Q. How to translate this? How to translate this? P is necessary for Q. P is necessary for Q. P is necessary for Q. How to translate this? This is same as if P does not happen, then Q does not happen. Okay, this is same as if not P, then not Q. If not P, then not Q. Okay, this is same as negation P implies negation Q. Okay, negation P implies negation Q. And do you remember I told you alpha implies beta? That is same as negation beta implies negation alpha. This we have already seen. We have already seen P implies Q is same as negation Q implies negation P. So tell me, negation P implies negation Q. Can I say that will be same as Q implies P? Yes or no? We have already seen alpha implies beta, that is same as negation beta implies negation alpha. Okay, so you can see P implies Q. We have already seen this is same as negation Q implies negation P. So can I say negation P implies negation Q, that is same as Q implies P? Yes. Okay, yes or no? Correct. So very simple point, that this I can also write as Q implies P. Okay, so that's it. This is the conclusion. So finally, remember, P is necessary for Q. What this actually means? See, this is very intuitive. P is necessary for Q. P is mandatory for Q. It means without P, Q cannot happen because P is mandatory. P is mandatory for Q. Means without P, Q cannot happen. Without P, Q cannot happen. Means if P does not happen, then Q does not happen. That is same as negation P implies negation Q, and that is same as Q implies P. Okay, so very simple. This A is necessary for B. A is necessary for B. Finally, you will write like this: B implies A. Is this clear? This is the conclusion, that A is necessary for B, we will write like this: B implies A. Or you can write like this, that if A does not happen, then B does not happen. Okay? Is this clear? Simple. Now let's move on now. Now let's see this example. Getting first rank in the GATE exam. Can I say that is necessary or sufficient for IIT Bombay MTech? Tell me. Is it necessary or is it sufficient? First rank is necessary, can I say? Can I say first rank is necessary? First rank is necessary to get IIT Bombay MTech? No, that is not necessary, but that is sufficient. You can get IIT Bombay MTech with second rank also, third rank also. Okay, yes or no? So if your rank is, I can say, maybe top 50, then you can get IIT Bombay. So can I say getting first rank is necessary? No, it is not necessary. It is sufficient. Getting first rank in GATE exam is sufficient. It is enough to get IIT Bombay MTech. So remember, it is sufficient. Okay, now what it means? Tell me. Tell me. So here, what it means? Does it mean that if you have first rank, you can get IIT Bombay MTech? Does it mean if you have first rank, you can get IIT Bombay MTech? Does it mean? Does it mean if you have first rank, you can get IIT Bombay MTech? Yes, this is what it means. Yes or no? This is what it means. Because if you have this, then that is enough. That is enough for IIT Bombay. Yes or no? If you have first rank, that itself is enough for IIT Bombay. Means if you have first rank, then you can get IIT Bombay MTech. So very simple point. Okay, so this is the idea. Now let's see this another example. Being a natural number, is that necessary for integer? Is that necessary for being integer? Being natural number, is that necessary for being integer? No, that is not necessary, but that is enough. If you are natural, then that is enough for being integer. Yes or no? But that is not necessary. For example, even -2 is also integer. This is also integer, but not natural. But not a natural. Yes or no? So you can easily see, if you are natural number, then that is enough. That is enough to be integer, but that is not necessary. Okay, for example, -2, that is also integer, but not natural. Okay, so I can say it is a sufficient. Yes or no? So this is the statement, it is sufficient. Now what it means? Does it mean integer implies natural or natural implies integer? Tell me, does it mean integer implies natural or does it mean natural implies integer? Tell me. It implies, it means natural implies integer. It does not mean integer implies natural. Okay, yes or no? So very simple point, because if you are natural, if this happens, then this will happen. Okay, if this happens, that is enough for this. So I can say natural implies integer. If you are natural, then it is a integer. Okay, very simple point. So the conclusion, where is the conclusion? Let me write. The conclusion is like this. When you see this statement, P is sufficient for Q, what this actually telling you? P is sufficient for Q. This simply means that if P happens, then Q will happen. Because P is sufficient. P is sufficient. So it simply means if P happens, then Q happens. And that is same as P implies Q. Okay, is this clear? Very simple. Okay, so P is sufficient Q. That means happening of P is enough for happening of Q. And that is same as P implies Q. Very simple. Yes or no? So that's it. Now let's move on. Let's see this example. Studying chemistry, that is necessary or sufficient for cracking the GATE computer science exam? Tell me. Studying chemistry, that is necessary or sufficient for cracking the GATE exam? Tell me. Cracking the GATE computer science exam, that is neither necessary nor sufficient. Yes or no? Very simple. Okay. Now, anyway, let me tell you one more thing. So finally, what we have seen, let me tell you, in the necessary and sufficient condition, what we have seen, let me tell you. And these are important, remember. So the conclusion is like this. See, when you see this statement, P is sufficient for Q, then how to write this? P is sufficient for Q. How to write this? P is sufficient for Q. This is same as P implies Q. Okay, this is same as P implies Q. And how to write P is necessary for Q? P is necessary for Q. How to write this? P is necessary for Q. This you will write as Q implies P. Okay. The logic I told you, yes or no? Will you ever forget this? Just remember the logic. Remember, P is mandatory for Q. What it means? It means if P does not happen, then Q does not happen. Means negation P implies negation Q. Okay, yes or no? Remember this. P is necessary for Q. I told you the logic. Okay, just remember the logic. The logic is very simple that P is mandatory for Q. P is mandatory for Q. So if P does not happen, then Q does not happen. Okay, so like this. Very simple. All these points, are they clear? So these are the conclusions. Okay. One more thing I want to tell you, and this is interesting. This is interesting. Look at this. If I give you this P implies Q, how can you write it? You can write it that this, remember, this is same as P is sufficient for Q. Yes or no? You know that I can read like this. P is sufficient for Q. Okay. But I can also say that Q is necessary for P. Yes or no? But I can also read like this. Q is necessary for P. Do you agree with me? See what I'm saying. Notice. P is sufficient for Q. That is same as P implies Q. Q is necessary for P. That is same as P implies Q. So they are basically P implies Q. Yes or no? Both are P implies Q. This is also P implies Q. This is also P implies Q. So can I say they are same? So can I say they are same? Yes, they are same. Yes or no? So remember, P is sufficient for Q. This statement is same as P is sufficient for Q. This statement is the same as this statement. Q is necessary for P. These two statements are same. Okay, these two statements are same. P is sufficient for Q. This statement is same as Q is necessary for P. So I can say if P is sufficient for Q, then I can say Q is necessary for P. And very simple. Yes or no? Is this clear? What I'm saying, I am saying that I'm saying if P is sufficient for Q, then Q will be necessary for P. Do you agree? Do you agree? If P is sufficient for Q, then Q will be necessary for P. Okay, because P is sufficient for Q, that means P implies Q. Q is necessary for P, that means P implies Q. Both are P implies Q. Both are same. These two things are same. Okay, yes or no? P is sufficient for Q. This and Q is necessary for P. These two statements are same. Okay, so if P is sufficient for Q, then Q is necessary for P. Okay, and you can see this because remember, P is sufficient for Q, you will write like this, P implies Q. And Q is necessary for P, you will write like this. So they are actually same. These two statements are same. This statement, they are actually same. Okay, let's move on now. Now let's see only if. Let's see this word only if. How to translate this in mathematics? Okay, so read this statement. You can join army only if you are male. Okay, so if you want to join army, then only if you are male. This statement, tell me, in many countries this statement is true, right? Do you agree with me? In many countries this statement is true. You can join army only if you are male. Only if you are male. Okay, in many countries this statement is actually true. Now tell me, in those countries what they want to say. Let's assume there is a country in which this statement is true. Means in that country, if you want to join army, then it is mandatory that you are male. Okay, you can join army only if you are male. So what this statement actually means, this only if, does it give you sufficiency or does it give you necessity? This only if, does it mean necessary or does it mean sufficient? It means necessary. It means mandatory. If you want to join army, it is mandatory that you are male. It is mandatory. So only if this is same as, this gives you necessary meaning, necessary or mandatory, the yes or no, this gives you the this gives you the meaning of necessary or mandatory. So what I can say, okay, this same statement I can say, you can join army only if you are male. Means if you want to join army, then it is mandatory that you are male. So I can say male, this is mandatory for army, yes or no? This is a necessary for army. Okay, this is necessary for army. Do you agree? This is necessary for army. Okay, these are same. So male is necessary for army. Okay, Yes or no? And tell me how to write this. Male is necessary for army. How to write this? This you will write as army implies male. Means if you are in army, then definitely you are male. Army implies male. Okay, is this clear? Yes or no? Because P is necessary for Q. That means Q implies P. P is necessary for Q. That means Q implies P. So male is necessary for army. That means army implies male. Okay, is this clear? Let me know. So very simple point. Remember, you can see. Tell me the answer for this question. Tell me the answer for this question. You can join army only if you are male. Only if you are male. Now this is equivalent to what? Is this equivalent to this or is this equivalent to this? Can I say if you are male, then you can join army? Or can I say if you are not male, you cannot join army? Which statement is correct? Yes, the second statement is correct. The first statement is not correct. Yes or no? Okay. So very simple. So remember, this is what this statement means, that if you are not male, then you cannot join army. Okay. Okay, maybe see the first statement is not correct because maybe the male, maybe that is maybe younger. Okay, maybe that is um, I can say less than 10-year-old. Okay, so being male is not enough. Being male is not enough. But I can say if you are not male, then you cannot join army. Okay, so anyway, I hope this point is clear. What is the important point? Let me tell you. The important point is, see, just understand the point. The point that is important, that is, this is P only if Q. Okay, how to translate this? This we will translate like this, that if you are in army, then definitely you are male. Do you agree with me? Do you agree with me? If you are in army, then definitely you are male. If you are in army, then definitely you are male. So this is how to translate. Okay. Or I can say that if you are not male, then you are not in army. That is same as if you are not male, then you are not in army. Okay. So the conclusion, let me tell you, the conclusion is, okay, let me tell you the conclusion. I hope you understood this. So the conclusion is, when you see this statement P only if Q, P only if Q, then you will write like this. Okay. You will write like this, that it is same as P implies Q. P implies Q. But I want to tell you one thing, that in future, if you forget how to write this, okay, if you forget how to write this P implies Q or Q implies P, how to write this, if you forget, then what you need to remember? Then what you need to remember? Remember that this simply means P only if Q. Okay, means Q is necessary for P. This simply means Q is necessary for P. Yes or no? This simply means Q is necessary for P. And that simply means negation P implies negation Q. Negation P implies negation Q. And that simply means Q implies P. Sorry, P only if Q. Sorry, yeah, this will be negation Q implies negation P. This will be negation Q implies negation P. And that is same as P implies Q. That is same as P implies Q. Okay. So very simple point. Remember, very simple. P only if Q. This only if simply means that Q is necessary. Okay. To join army only if you are male. Okay. You can join army only if you are male. That simply means that being male is mandatory. So here Q is necessary for P. That means if Q does not happen, then P does not happen. Okay. And that is same as P implies Q. Okay. So anyway, this is the conclusion. You can remember this conclusion, that P only if Q, that is same as P implies Q. And remember, P if Q, how to write this? P if Q, P if Q, that is same as, see, I can write like this, if Q then P. Yes or no? P if Q, I can say if Q then P, and that is same as Q implies P. Okay. So very simple. So let me write it side by side. Let me write it side by side. You will never forget it. Okay, see, when you see this statement, if P if Q, then remember, you can write it as if QP. Okay, you can write it as, just change it, if QP. Then now it is very easy. Now it is very easy. Q implies P. Okay, and similarly, when you have P only if Q, then that is a simple P implies Q. Okay, so it is like this, that only if this goes in the forward direction. Okay, the trick to remember, if you want to remember it, only if goes in the forward direction. Okay, yes or no? But it should be in between. Yes or no? For example, don't make this mistake. For example, if I say only if, tell me now, only if QP, how to translate this? How to translate this? Only if PQ. How to translate this? Only if PQ. Very simple. First you write it in between. First you write it in between. Q only if P. Now it is very simple. Q implies P. Okay, all these points, are they clear? Let me know. Very simple. Okay. Now let's see various English translations of P implies Q. This P implies Q. This has many English translations. Did you notice one thing? This P implies Q, we can write in many different ways. Okay, so far what we have seen, can you tell me? So far, what are the English translations that you have seen? Tell me. This, how to write this in English? Very simple. You can write like this. P implies Q. This is very simple. P implies Q. Or you can write like this. If P then Q. Okay. Or you can write like this. When P then Q. Okay. Very simple. Or you can write like this. If P comma Q. Okay. Or you can write like this, that P is sufficient for Q. Yes or no? P is sufficient for Q. Or you can write like this. P only if Q. Correct? P only if Q. Or you can write like this, that Q is necessary for P. Q is necessary for P. Tell me. Understood? Let me know. All these are all these are the different English translations of P implies Q. Okay, you can read this. One more thing I want to tell you, that in logic these words are same. In logic these words are same. If, when, whenever, these words are same. So let me write it. Okay. In logic, all these words, they are same. So if, when, whenever, provided that, given that, all these words are same. So when you see this word, just remove it and write if. For example, if I give you this statement, P provided that Q, provided that Q. Okay, this is same as what? Just remove it. Just remove it and write if. Now tell me what this means. This simply means if Q then P, and that is same as Q implies P. Understood? Let me know. So these words are same. If, when, whenever, provided that, given that. All these words are same. Okay. So it means I can also write like this. Whenever P, then Q. Whenever P, then Q. Whenever P happens, then Q happens. Okay. I can also write like this, that provided that P, then Q. Provided that P, then Q. Okay, so many different ways. Yes or no? Do you agree with me? There are many different ways and all are important. Okay, so you can see if P then Q, that means P implies Q. That means P implies Q. And these are the different ways. If P then Q, if P comma Q, P is sufficient for Q, Q if P, Q when P, a necessary condition for P is Q. Yes or no? Look at this. A necessary condition for P is Q. This unless we will see. Don't worry. Okay, this we will see in future. Okay, in this lecture, at the end, we will see. We will see at the end. We will see in this lecture. Okay, in the lecture. Don't worry. Don't worry about it. We will see in this lecture. Okay, so don't worry about it. Now you can see P implies Q. P only if Q. A sufficient condition for Q is P. P, Q whenever P. Okay, so very simple. You can see Q follows from P. Okay, so these are different English translations. I hope all are clear. Let me know. Can I say you are confident? If I give you any statement, can you write it? Let me know. For example, okay, just see this question. If I say that a sufficient condition, I am writing this, a sufficient condition for P is Q. Tell me how to write it. Let me know how to write it. A sufficient condition for P is Q. Very simple. Here, who is sufficient? Tell me who is sufficient. Let me know. A sufficient condition for P is Q. So this means Q is sufficient for P. Q is sufficient for P. And now this is very simple. This is Q implies P. Yes or no? Now this is very simple. Q implies P. Okay. So like this you can understand. And same thing if I say necessary. Now tell me, for example, a necessary condition for P is Q. Who is necessary? Q is necessary. So remember, Q is necessary for P. And how to write it? Very simple. That is P implies Q. Okay. So we have seen all of them. Everything we have seen. Everything related to implication we have seen. Now we will see the next logical connective, that is by implication. But tell me, did you understand implication? We have seen everything about implication, all the important properties, the behavior of implication, the terminology, and different English translations of implication. Tell me, did you understand? These are important. Okay, this sufficient and necessary. I told you what is sufficient condition, what is necessary condition. I told you what is only if. Okay, everything I told you. Yes or no? Now let's move on. Now we will see the next connective, that is by implication. This is our next logical connective. And the name itself is telling you by implication, means two ways implication. Okay. So let's see what is this by implication. Another name, that is by conditional. Another name is by conditional. Because implication means conditional. So another name is by conditional statement. Or I can say by implication statement. Now, what is the symbol for this? So this by implication, what is the symbol? The symbol is a two ways implication. This is the symbol. Okay, means both the sides. So this is the symbol for by implication. Okay. There is another symbol that is like this. This is another symbol. In digital logic, we use this symbol, but in propositional logic, we use this symbol. Okay, but they are fine. Okay, they are same. Now let's see what is this P by conditional Q. Remember how to read this? How to read this? Because this is your by conditional. Okay, so P by conditional Q. P by conditional Q. So what this means? P by conditional Q. This, remember, this is same as basically both the sides implication. Here you can notice P implies Q and you can notice Q implies P. So P implies Q and Q implies P. Okay, so how to read this? You can read like this, that P implies Q and vice versa. P implies Q and vice versa. Like this you can read, because P implies Q and Q implies P. Is this clear? So this is how you can read it. But this is important property, that this P by conditional Q, the name itself is telling you by conditional, by implication, means implication in both the directions. So here you can notice P implies Q and Q implies P. Okay, here P will imply Q and Q will imply P. So let's see the truth table. Now let's see truth table of biconditional. So to create the truth table of this biconditional, first you tell me about the truth table of P implies Q. Then you tell me the truth table of Q implies P. And then we will do their conjunction. Then we will do their AND. Correct? Yes or no? So remember, let's create the truth table. What will be the truth table? Tell me. The truth table of implication you already know. This P implies Q. This is false only in one case, when P is true, Q is false. Okay. So only in this case it will be false. In all other cases it will be true. Okay. What about Q implies P? This will be false only in one case, when Q is true, P is false. Okay. So when Q is true, P is false. Only in this case it will be false. In all other cases this will be true. Now let's do the AND, because P by conditional Q, that means P implies Q and Q implies P. So let's do the AND of these two. So what will be that? True and true, that is true. True and false, that is false. False and true, that is false. True and true, that is true. Okay, is this clear? So very simple. Is this clear? So this is the truth table of P by conditional Q. Did you notice one thing, that this by conditional, when this is true when P comma Q are same. Yes or no? This is true when P comma Q are same. So these are some important points, that this P by conditional Q, when this is true, tell me, Tell me when this is true. This is true when P comma Q are same. Okay, when P comma Q are same, you can see, you can notice this biconditional. This is true. This is true when P comma Q are same. Either both are false or both true. So I can say when both are same, then this is true. And did you notice one thing? That this P biconditional Q, this is opposite of, this is negation of exclusive or. Did you notice this is a negation of XOR? Because you can see, okay, what is XOR? XOR is like this, FTTF. This is XOR. This is a XOR. Yes or no? P XOR Q. This is XOR. So did you notice they are negation of each other? They are negation of each other. Yes or no? I can say P XOR Q, that is negation of biconditional. So they are negation of each other. And very simple, this biconditional, this is true when they are same, when P comma Q are same. Either P comma Q both false or both true. And this is the truth table, TFFT. Very simple. Okay. So this is the idea. Remember, P biconditional Q. This simply means P implies Q and Q implies P. Okay. This is what it means, that P implies Q and Q implies P. Simple. Okay. Now let's move on. So you can see this is the truth table of biconditional. Okay. You can easily see that this biconditional, this is true when P comma Q are same. Now let's see various English translations of by implication. What are different English translations of by implication? So this is actually very simple. You know that by implication, okay, that is same as what? That is same as P implies Q and Q implies P. So let me write it like this, that this is same as Q implies P and P implies Q. Agree? Do you agree? Okay. Now you tell me what this means. Tell me what this means. Q implies P. What this means? This means, tell me what this means. This means P if Q. Yes or no? Do you agree? This means P if Q. And what this means? And what this means? This means P only if Q. Yes or no? P implies Q. That means P only if Q. And Q implies P. That means P if Q. Now you combine them. Now you combine them. P if Q and P only if Q. Now if you combine them, what you will get? You will get P. You will get P if and only if Q. Is this clear? You will get P if and only if Q. So this is how you will read P biconditional Q. Okay, how to read this? This is how you will read P if and only if Q. Did you understand? Let me know. Let me know, did you understand what this if means? Tell me what this if means. This if means Q implies P. And what this only if means? What this only if means? Only if means Q implies P implies Q. Okay, and there is and here. This and this. Okay, is this clear? Please tell me, did you understand? Let me know. Remember, if means Q implies P, only if means P implies Q, and there is and here. And there is and here. So that's it. Okay, very simple. So this is how you will read P if and only if Q. Okay, this biconditional, we will read like this P if and only if Q. In short, you will write like this P IFF Q. What this IFF means? This means if and only if. This IFF, this means if and only if. Okay, IFF means if and only if. Okay, one more thing I want to tell you. See what this means in the necessary comma sufficient case. What this means here, who is sufficient and who is necessary? Tell me. Q implies P. Here, can I say here P is necessary? Here P is necessary, right? I can say here P is necessary for Q. Do you agree? Here P is necessary for Q. Okay, P is necessary for Q. Okay, and what this means? What this means? Here P is sufficient for Q. Here P is sufficient for Q. Okay, now what is their and? Now do their and, because there is and here. Okay, now do their and. If you do their and, what you will get? Remember, P is necessary for Q and P is sufficient for Q. In one line, what you can write? In one line, you can write P is necessary and sufficient for Q. P is necessary and sufficient for Q. In one line, you can write like this, that P is necessary and sufficient for Q. Understood? That's it. Okay, so necessary and sufficient. Remember, necessary and sufficient. That is same as what? That is same as if and only if. That is same as if and only if. This necessary and sufficient. This is same as if and only if. Okay, so that's it. So this is our English interpretations. So finally, you can see P biconditional Q. How to read? Very simple. P if and only if Q. P if and only if Q. Or I can say if P then Q and conversely or vice versa. Don't worry, we will see what converse means. What this converse means, we will see. Don't worry. P is necessary and sufficient for Q. I can also say P if and only if Q. P if and only if Q. I can also say if P then Q, if P then Q and vice versa. If P then Q and vice versa. Okay, so that's it. Is this clear? So far, every concept is clear. Let me know. So we have seen biconditional. This P biconditional Q, this we have already seen. Okay, I told you biconditional means if and only if. This biconditional, this simply means if and only if. P if and only if Q. Okay, let's move on now. Now let's see precedence order of logical connectives. What is the precedence order? Priority order. Okay. See, in mathematics, you know what is the priority order, right? In normal mathematics, in our regular mathematics, what is the priority order? You already know. Tell me one thing. If I say 1 or uh, sorry, A plus B multiplied by C, what this actually means? What this actually means? Does it mean A plus B multiplied by C, or does it mean A plus B multiplied by C? What it means? In our regular mathematics, you tell me this expression A plus B multiplied by C, what this means? Yes, this means this one, right? Yes or no? Because multiplication has more priority than addition. This multiplication, it has more priority than addition. Correct? Okay, so first you will do multiplication, then you will do addition. First you will do multiplication, then you will do the addition. Okay, now same thing in the propositional logic. In the propositional logic also we have priority order, and the priority order is like this. Bracket has highest priority. Yes or no? Bracket has highest priority, then negation, then conjunction, then disjunction, then implication, and then by implication. Okay, so this is the priority order. Very simple. Bracket always has highest priority, then negation, conjunction, disjunction, implication, by implication. Okay, so for example, if I give you this expression, P implies Q or R, what this actually means? Does it mean P implies Q, first you do P implies Q or R, or does it mean that first you do Q or R, then you do P, then you do implication? Yes, this is correct, this is wrong. Okay, because you can see this disjunction has more priority than implication. So first you will do disjunction, first you will do or, then you will do implication. Okay, so this is the priority order. You can easily see here that, remember, bracket always has highest priority. This bracket, it will always have highest priority. After that, negation, conjunction, disjunction, implication, by implication. This is the priority order. For example, if you have this P or Q and R, what this means? This actually means first you will do conjunction. Yes or no? This actually means that first you will do conjunction, because conjunction has more priority and has more priority than or. Okay, so first you will do Q and R. Okay, very simple. So this is the idea. Now let's see the next concept, that is propositional formula. What is this concept? Propositional formula, or I can say propositional expression, or I can say compound proposition. So what is this concept? Compound proposition or propositional formula. Let's see this. Let me tell you that these two things are same. Compound proposition and propositional formula, these two things are same. You can see this. Okay. So You can call it compound proposition or you can call it propositional formula. They are same. Different people, they use different words. Okay, some people they use this word, some people use this word, but they are same. Now let's see what it means. Propositional formula or propositional expression. Propositional formula. You can also call it propositional expression. You can also call it propositional expression. Okay, you can also call it compound proposition. Okay, all these are different names for the same thing. Is this clear? So what is propositional formula or propositional expression? This is very simple. It is very simple. For example, any expression that you can write. Okay, any expression you can write, that is your propositional formula. Okay, for example, what are the expressions you can write? Let's assume your propositional variable p comma q. Let's assume your propositional variables p, q, r. Let's assume these are the variables. Okay, then what are the expressions you can write? Then what are the propositional expressions you can write? Expression means formula. What are the propositional expressions you can write? You can write this expression. Yes or no? This expression you can write. You can write this expression. You can write this expression. This is also expression. Okay, this is also expression. This is also expression. This is true. This is false. Yes or no? You can write P implies Q. You can write like this: P and P implies Q. Okay, you can write negation P or Q implies R. So you are getting the idea, right? Yes or no? You are getting the idea that basically using the logical connectives, whatever you want to write, you can write. This is also called well-framed formula. WFF, that means well-framed formula. This is also called well-framed formula. Is this clear? So basically, using logical connectives, whatever you can write, that is your propositional formula. Remember, every propositional variable is also a formula. This Q is also a formula. R is also a formula. Okay, negation R is also a formula. Negation R XOR Q, that is also a formula, and so on. Okay, you are getting the idea. Yes or no? Is this clear? Please tell me. Let me know. Did you understand? So all these things are same. Remember, propositional formula. Another name is WFF, well framed formula. Okay, WFF, that is well framed formula. Okay, what this means? This means well framed formula. And this is another name for compound proposition. Compound proposition. Or you can call it propositional expression. So all these things are same. Okay. So very simple point. I hope you are getting this point. Okay. Now, let me tell you one more thing. If you have studied this Boolean algebra in digital logic, we study Boolean algebra, right? Okay. So in Boolean algebra, we have this Boolean function, right? In Boolean algebra. If you did not study, then don't worry. But if you have studied this Boolean algebra in digital logic, maybe in your college life, you have seen this Boolean algebra. Okay. So in Boolean algebra, if you remember, there is something called Boolean function. Okay. There is something called Boolean function. First, let me tell you, in Boolean algebra, you have Boolean variables. In Boolean algebra, you have Boolean variables like A, B, C, right? Yes or no? A, B, C, like that. So that is same as your propositional variable. Okay, your Boolean variables like A, B, C, they are same as your propositional variables. Okay, here we have propositional variables like P, Q, R. Okay, yes or no? So Boolean variable is same as propositional variable. And in Boolean algebra, you have Boolean functions, right? You have Boolean functions. In Boolean algebra, you have Boolean functions. Okay, they are same as your propositional formula. They are same as your propositional formula. Okay, so very simple point. This is a very simple point here. So if you have Boolean variables, like if you remember, let me tell you, in Boolean algebra, what you do? In Boolean algebra, you have A, B, C, basically Boolean variables you have. Okay, in Boolean algebra. In Boolean algebra, there are Boolean variables. First, you have Boolean variables. Okay, most of the time we use variables like A, B, C, D. Okay, these variables we use A, B, C, D. These are Boolean variables. Okay, now what are Boolean functions? Can you tell me some Boolean functions? Can you tell me some Boolean functions? We have Boolean function in Boolean algebra. We have Boolean functions. Okay, what are Boolean functions? Can you give me some Boolean functions? For example, I can say this is a Boolean function A or B. Okay, there is another Boolean function A and B. There is another Boolean function A bar. Okay, for example, A bar or B. Okay, for example, A or B C. Okay, yes or no? A bar or B C bar, and so on. Okay, you are getting the idea. Yes or no? And remember, A itself is a Boolean function, B itself is a Boolean function, C itself is a Boolean function, 0 is a Boolean function, 1 is a Boolean function. Okay, I can say A bar is a Boolean function, B bar is a Boolean function, and so on. So you are getting the idea. The same thing we have in the propositional logic. The same thing we have in the propositional logic. In propositional logic, what we have? In the propositional logic, we have propositional variables. In the propositional logic, we have propositional variables. They are like PQR. Okay, here you have ABCD, here you have PQR. Okay, and here you have propositional functions, formulas. Here you have propositional formulas. What are propositional formulas that you already know? P is a propositional formula, Q is a propositional formula, true is a formula, false is a formula, P bar is a formula, P or Q is a formula, P implies Q is a formula. Yes or no? For example, negation P or P implies Q, that is a formula, and so on. Okay, so that's it. Yes or no? Is this clear to everyone? The difference is clear. The similarity is that clear? Let me know. Okay. One more thing I want to tell you. In Boolean algebra, these Boolean variables, you have A, B, C, D. Can I say they are atoms? You cannot break them. Yes or no? You cannot break them. For example, consider the difference. Okay, look at this. P implies Q. Can I say this is breakable? Yes, I can break it in P, Q. There is implication. Okay, so remember, this is a propositional formula. But here, this P, this is a propositional variable, and you cannot break this P. Yes or no? Do you agree? See, this entire thing is propositional formula. This entire thing is propositional formula. But inside this P, this is a propositional variable. Okay, and you cannot break it. This is atomic. You cannot break it. Yes or no? Unbreakable. You cannot break it. This is atomic. So remember, propositional variable, that is also called atomic variable. That is also called atomic proposition. That is also called atomic proposition. Okay, is this clear? And this proposition formula, this is also called compound proposition. And remember, every atomic proposition is also compound proposition, right? Yes or no? Yes or no? Every propositional variable is also a propositional formula. Okay, very simple. So you can see. So we have already seen this. I hope this point is clear. Let me know, is this clear? What is propositional formula and what is propositional variable? The difference is clear to everyone. Propositional formula versus propositional variable. Yes or no? So this is a propositional formula. Any expression that you can write using logical connectives and propositional variables, any expression that you can write, that is your propositional formula. And this P comma Q, they are propositional variable. You cannot break them. They are atomic. So they are called atomic variable, or you can call them atomic proposition. So propositional variable is called atomic proposition. Okay, and this is proposition formula. You can call it compound proposition. And remember, every proposition variable is also a propositional formula. Yes or no? Every propositional variable. Proposition variable means atomic proposition. Every propositional variable is a propositional formula. But can I say the reverse direction is correct? Can I say? Can I say every propositional formula is a propositional variable? Can I say this is a propositional variable? This, no, this is not a variable. This is a variable. This is a variable. P comma Q are variable. Yes or no? So every propositional variable is a propositional formula, but not vice versa. But not vice versa. Okay, so this is a simple point, very simple. So I hope you understood what is propositional formula. The concept is actually very simple. You can see what is proposition formula or compound proposition. compound proposition, they are same thing. So any expression you can write. Remember, these are propositional variable PQR. They are atomic propositions. You cannot break them. Now, with the help of logical connectives, whatever you can write. For example, you can write this expression. You can write this expression. Okay, P implies Q. Remember, this propositional variable. This is also propositional formula, and so on. Okay, so I hope you understood. This is the formal definition. If you want formal definition of propositional formula, then what is that? Very simple. True comma false, they are propositional formula. Every propositional variable is a propositional formula. For example, P, Q, R, they are propositional formula. And remember, with the help of logical connectives, or, and, negation, bracket, implication, by implication, with the help of logical connectives, whatever formula you can write, that is also propositional formula. Okay, very simple point. Is this clear? So these are propositional formula. This is also formula. This is also formula, formula, formula. But this is variable. This is propositional variable, and all of them are propositional formula. This is atomic proposition, and all of them are compound proposition. Remember, this is atomic proposition. All of them are compound proposition, because proposition formula, another name is compound proposition. Okay, very simple. We have already seen. Now let's move on. So we have seen this. Atomic proposition means propositional variable. Okay, propositional variable, that is your atomic proposition. And we have seen what is propositional formula. For example, this is a propositional formula. Yes or no? A and B or C implies B. This is a propositional formula. You can see this. Okay, very simple. Now let's see. Now let's see the concept of truth table. This you already know, but for formality, let me tell you what is truth table of propositional formula. If you have a propositional formula, then what is the truth table of this formula? That is very simple. Truth table tells us what is the truth value of a propositional formula, what is the truth value of a compound proposition for each combination of truth value of atomic propositions. Okay, this is very simple definition, that for each combination of truth value of compound uh, of atomic propositions, what is the truth value of the compound proposition. Okay, so for example, this is your propositional formula. Yes or no? Now what I will do, I will create the truth table. What truth table means? First of all, you can notice here, please notice here, this is a formula. Yes or no? I can call it compound proposition, or I can call it propositional formula. This is our propositional formula. Okay, or I can say this is our propositional expression. Now here, this is your atomic proposition, this is your propositional variable. Okay, similarly this is also propositional variable. Now what truth table means? Truth table means that for every truth value combination of propositional variables, for every truth value combinations of P comma Q, what is the truth value of this formula? Okay, is this clear? For every truth value combination of atomic propositions, what is the truth value of the compound proposition? Okay, so let's see. Here you can see you have P, you have Q. These are the propositional variable. So tell me, how many truth value combinations are possible? There are 4 truth value combinations are possible. Yes or no? 4 truth value combinations are possible. Maybe both are false. P is false, Q is true, P is true, Q is false, and both are true. So these are the 4 truth value combinations of P comma Q, because they are propositional variable. So either P is true or P is false. Okay, the truth value of P is one of them. Similarly, the truth value of Q is one of them. Okay, so 4 truth value combinations are possible. Now tell me, what is the truth table of P and P implies Q? For every truth value combination of PQ, what is the truth value of this expression? Tell me, for every row, what is the truth value of this expression? For the first row, this expression will become false. Okay, yes or no? You can easily see, because P is false. If P is false, then P and false and anything, that is false. Okay, here also P is false, false and anything, that is false. Now, what about this one? True comma false. Here you can see, for this truth value combination, you can see P implies Q will be false. Okay, true implies false, that is false. So I can say again you will get false, and here you will get true. So this is the truth table. Okay, so very simple point. You can see the truth table. For this, the truth table will be, that will be false, 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 true. This will be the answer. Okay, now let's move on. You can see this is the truth table of this expression. Okay, so you can easily do For this expression, if I tell you to write truth table, then you can see there are four combinations PQ. There are four truth value combinations are possible, and this will be the truth table. Okay, let's move on. Create the truth table for compound proposition. This is the compound proposition. For this, we need to create the truth table. You just tell me one thing. How many how many truth value combinations will be there? How many truth value combinations will be there? You have two variables PQ. You have two variables PQ. So four truth value combinations will be there. Okay. And for each combination, you can find what is the truth value of this expression. Okay. So let me quickly write it. You tell me for every combination, because you have two variables. So for two variables, there are four truth value combinations. We have these combinations. Both are false. P is false, Q is true. P is true, Q is false. Both are true. So tell me this expression, let me call it S. Okay, for formality, let me call it S. So tell me, or maybe I can call it H. Now tell me, what will be the truth value of this H? For this combination, what is the truth value? When P is false, Q is false, then what is the truth value of H? You can see P false, Q false. Okay, because P false, Q false, so P and Q will be false. Okay, and you can see this will be true. True implies false will be false. So finally, you will get false. Next, for this combination, you can see this will be false. Okay, next, you can see for this combination, this also will be false. False implies false, that will be true. Okay, false implies false, that will be true. What about the next? For this combination, what will be truth value of H? For this combination, you can see this will be false. And what about this? This will be true. True implies false, that is false. Yes or no? Is this clear? What about next? What about this one? When both are true. When both are true, then this will be true. Anything implies true will be true. Anything implies true, that will be true. Anything implies true, that is always true. Okay. So, very simple. So, this is your answer. FT, FT. Is this clear? This is the truth table of this expression H. Very easily you can write. Okay. Now, let's move on. So, did you notice one thing? Creating the truth table, that is boring and inefficient method. Yes or no? You also agree with me that creating truth table, that is inefficient, time consuming and boring method. So let me tell you, we will rarely use truth table to solve questions. We will never use truth table to solve questions. Let me tell you, we have different ways. Some analytical methods are there to solve questions, but we will never use truth table. Okay, so this is the point, because truth table will take a lot of time. It is inefficient, boring and time consuming. Okay. Now let's see the next concept, that is tautology, contradiction, contingency in propositional logic. What are these concepts? What is tautology? What is contradiction? What is contingency? And these are very simple concepts. These are just definitions. Just understand the definition and these concepts are over. So if you have a propositional formula or propositional expression, so if you have a propositional expression, let's assume H, okay, or G, whatever. So let's assume this proposition expression H you have. Now, when can I say this is tautology? What is the definition of tautology? Let's see. When can I say H is tautology? H is tautology. So what is the definition of tautology? H is tautology means H is always true. Remember, tautology means always true. That's it. H is tautology if H is always true. Okay, in truth table, for every row, this H is true. So tautology means always true. And what is contradiction? What is contradiction? These definitions are very simple. Just understand the definition and you can easily solve the question. What is contradiction and what is contingency? So what is contradiction? Contradiction means always false. Contradiction means always false. Okay. So if H is always false, then H is contradiction. If H is always true, then H is tautology. And the last is contingency. Contingency means H is neither tautology nor contradiction. Okay. Contingency means at least one time true, at least one time false. Okay. So contingency means at least one time true. Okay. At least one time true and at least one time false. Means neither contradiction nor contingency. Is this clear? At least one time true, at least one time false. So these are the definitions of tautology, contradiction, contingency. Is this clear? H H is tautology if it is always true. H is contradiction if it is always false. And if it is neither tautology nor contradiction, then H is contingency. Okay, is this clear? If H is neither tautology nor contradiction, then it is a contingency. Contingency means at least one time true and at least one time false. Okay, very simple. Now you can easily see, look at this expression P or P bar. Look at this. This is always true, right? P or P bar. This is always true. So this is tautology. Because this is always true, so this is tautology. And look at this P and P bar. This is always false. So this is contradiction. Look at this P implies Q. This is sometimes true, sometimes false. So this is contingency. Look at this. This is neither tautology nor contradiction. So this is contingency. Similarly, this at least one time true, at least one time false. So this is contingency. You can see this is neither contradiction nor tautology. So this is contingency. Okay, so these are the definitions. Tautology is a proposition that is always true. Tautology means always true. Contradiction means always false. So contradiction is a proposition that is always false. Contingency is a proposition that is neither tautology nor contradiction. If something is neither tautology nor contradiction, then it is contingency. Okay, you can see this is always true, this is always false, and you can see this is sometimes true, sometimes false. Okay, so very simple. Now, so these are the definitions we have already seen. For example, look at this P or P bar. This is always true. If you create the truth table, this is always true. So this is tautology, P or P bar, because this is always true. Look at this expression. Is this tautology or contradiction or contingency? What is this? Tell me, for this expression, P or negation P or negation of P and Q. This is always true, so this is tautology. Okay, because this is always true, so this is tautology. And what about this? What about this one? Let me know. So here you can notice that this is a tautology. Okay, yes or no? This is tautology. What about this one? This is contingency, because you can see this is neither tautology nor contradiction. This is sometimes false, sometimes true. So this is a contingency. Okay, this one is a contingency. What about this one? What about this one? This is also contingency, because this is neither contradiction nor tautology. So this is also contingency. Okay, this is also contingency. What about this P? What about this P? You can see this is also contingency. Okay, and what about this Q? You can see this is also contingency. Understood? The definitions are very simple. Okay, you can see these are contradictions. P and negation P. This is contradiction. This is also contradiction. You can easily prove it. Let's see the B. PQ. Okay, so tell me, contradiction means always false. Contradiction means always false. So let's see this option B. This option B, that is P or Q and P bar and Q bar. Okay, so tell me, for this combination, what will be option B? For this truth value combination of PQ, what will be the truth value of option B? That will be false. You can check it, because P false, Q true, P false, Q false, P false, Q false. So this will be true, this will be true, but this will be false. False and true, that is false. Yes or no? False and true, that is false. So very easily you can see that for this combination, option B, that is false. Similarly, you can see for every combination, option B will be false, because it is always false. Because option B is always false. You can put it. See, for this combination, let's check for this combination. For this combination, you can see that this will be false, this will be true, and this will be true. You can see false and anything, that is false. False and anything, that is false. Okay, so you can see for every combination, this is a false. Option B is false, because option B is always false. Because option B is always false. So that is a contingency. Okay, so they are contradiction because they are always false. Because they are always false, so they are contradiction. Okay, very simple. So the definitions are actually very simple. Tell me the answer for this question. Which of the following propositional logic expressions are tautology? What about this propositional variable P? What about this variable P? Tell me. What about this variable P? This is contingency. Okay, this is a contingency because you can see either it will be true or it will be false. Either it will be true or it will be false. So you can see sometimes true, sometimes false. So this is actually contingency. Do you agree? So this propositional variable, that is contingency. Similarly, what is P bar? P bar will be false, true. So that is also contingency. Yes or no? That is also contingency. What about T implies P? You know that alpha implies beta. That is same as alpha bar or beta. Yes or no? So what is T implies P? That is same as T bar or P. What is T bar? Negation of true, that is false. False or P, that is P. Yes or no? False or P, that is a P. So finally, I can say that this is a contingency. Okay, because this is same as P. So this is contingency. Because remember, this is same as P. You can see true implies P, that is same as P. Okay, this is the proof because alpha implies beta, that is same as alpha bar or beta. Okay, so you can see T implies P, that is same as T bar or P. T bar is false. False or P, that is P. Yes or no? So very simple. What about P implies P? Tell me what about P implies P? P implies P. I can write like this: P bar or P. P bar or P, that is always true. Yes or no? That is always true. So this P implies P, that is a tautology. That is tautology. What about the next? P implies P bar. That is contingency, you can check. That is a contingency. Why? What is the reason? Because P implies P bar. That is same as P bar or P bar. That is same as P bar. So that is contingency. Okay. Very simple. What about the next? This is also contingency. This is also contingency. Okay. What about the next? That is tautology. True. True is a tautology because it is always true. So this is tautology. False. This is always false. So this is contradiction. This is a contradiction. And what about P implies F? P implies F. That is same as P bar or F. That is same as P bar. So this is also contingency. This is also contingency. Is this clear? Let me know. So this is the answer for this question. Very simple, very easy. So we have already seen that if you have a propositional formula, then when can you call it tautology, when can you call it contradiction, and when can you call it contingency? Okay. Another name for contradiction is a fallacy. Another name for contradiction, that is fallacy. Okay, but this is not a famous name. Okay, you can forget about it. This is contradiction. Okay, you can forget about it. This is a contradiction. This is not a famous name. Fallacy, this is not a famous name. The famous name is contradiction. Okay, you can say this should be contradiction. Simple. Okay, is this clear? Now let's move on. Now let's see the next definition, that is satisfiable, valid, falsifiable. Okay, what are these terms? Again, these are just definitions. Just understand the definition, remember the definition, and you can solve any question. What is the meaning of satisfiable? What is the meaning of valid? And what is the meaning of falsifiable in propositional logic? So let me tell you what satisfiable means. If you have a propositional formula, if you have a propositional expression, or I can say if you have a propositional formula, I give you a propositional expression H. Now, when can I say it is satisfiable? What is the meaning of satisfiable? What is the definition of satisfiable? So let me tell you. The definition is very simple. The name is telling you satisfiable means we can satisfy it. Means we can make it true. We can make it true. So satisfiable means there is some way to satisfy this. There is some way to make it true. Means this is at least one time true. That's it. At least one time true. That's it. At least one time true. That's it. It can be always true, but That is not necessary. It can be always true. It simply means at least one time true. This is the definition of satisfiable. Satisfiable means at least one time true. So what can I say? Tell me, who is satisfiable? Tautology or contradiction or contingency? If you want to become a satisfiable expression, when can this H become satisfiable? This will be satisfiable if it is tautology or contingency. Yes or no? Very simple. Satisfiable simply means either it is tautology or it is a contingency. Either it is tautology or it is a contingency. Because tautology or contingency, they simply means they are at least one time true. Okay, this is the definition of satisfiable. Satisfiable means there is some way to satisfy this. There is some way to make it true. Means at least one time true. That simply means either it is tautology or it is contingency. Okay, tell me what is the definition of valid? Valid is same as always true. Valid is same as always true. Valid means always true, and that is same as tautology. So tautology and valid, they are same. Okay, in propositional logic, remember, valid and tautology, they are same. Tautology and valid, they are same. Okay, and what is the third thing? That is falsifiable. The name itself is telling you. Tell me what this means. Falsifiable. What it means? Falsifiable. The name itself is telling you what this means. Falsifiable. See, satisfiable means there is some way to satisfy. Satisfiable. Okay, see, understand. Satisfiable means there is some way to satisfy, means there is some way to make it true, means at least one time true. Falsifiable means at least one time false. Falsifiable means at least one time false. At least one time false. Okay, is this clear? Falsifiable means at least one time false. So that is same as what? That is same as contradiction or contingency. Yes or no? Contradiction or contingency. Either it is contradiction or contingency. These definitions are clear. H is falsifiable if you can make it false. At least one case. In at least one case, you can make it false. Okay. So falsifiable simply means at least one time false. That means contradiction or contingency. Okay. In propositional logic, valid means tautology. They are same. Valid and tautology, they are same. Valid is same as tautology. That's it. Okay. They are same. Valid, tautology, they are same. Is this clear? Let me know. So these definitions are clear. Satisfiable means in at least one case you can make it true. Falsifiable means in at least one case you can make it false. These definitions, are they clear? Please tell me. Very simple definitions. When can I say something is falsifiable? Falsifiable means at least one time false. Okay. And valid means tautology. So you can see this chart. This is a beautiful chart. Okay. You can see here. What is always true? Tell me. Quickly tell me what is always true. You can see always true is tautology. Or I can say valid. Tautology and valid, they are always true. Okay. Yes or no? And what is the meaning of unfalsifiable? Can you tell me? You know what is falsifiable. So can you tell me what is unfalsifiable? See, falsifiable means what? Falsifiable means at least one time false. At least one time false. So tell me, unfalsifiable will mean what? Unfalsifiable. Falsifiable means there is at least one row where it is false. At least one row where it is false. Unfalsifiable means it is always true. Never false. Yes or no? Unfalsifiable means never false. Agree? Never false. That is same as always true. That is same as valid. That is same as tautology. Understood? Okay, yes or no? Now tell me, what is unsatisfiable? What that will mean? Unsatisfiable. What that will mean? See, satisfiable means at least one time true. Satisfiable means at least one time true. So unsatisfiable means never true. You can never satisfy. Yes or no? Satisfiable means at least one time true. Unsatisfiable means you can never satisfy, means never true, means always false. Always false means contradiction. Okay, I hope all these points are clear. So this table, you can see this is a beautiful table. What is sometimes true, sometimes false? What is sometimes true, sometimes false? That is contingency. Contingency is a sometimes true, sometimes false. Yes or no? Now, what is satisfiable? Satisfiable is from here to here. Satisfiable means either tautology or contingency. That is satisfiable. Yes or no? Satisfiable is tautology or contingency. Yes or no? What is invalid? Invalid means not tautology. Okay, valid means tautology. Invalid means not tautology. So invalid means contradiction or contingency. Yes or no? Is this clear to everyone? All these points, are they clear? Let me know. So these are the definitions. I hope everything is clear. You can see when something is satisfiable, alpha is satisfiable. What that means? Alpha is satisfiable, means you can satisfy it. Okay, means sometimes it is true. Okay, in at least one case it is true. Alpha is satisfiable if it is true in at least one case. So satisfiable simply means either tautology or contingency. Okay, tautology or contingency. Satisfiable means at least one time true. Unsatisfiable means never true, means always false. Unsatisfiable and contradiction are same. Unsatisfiable and contradiction, they are same. Let's see this. Tautology is same as valid. Valid means always true. Invalid means no tautology. No tautology means either contradiction or contingency. Contradiction is same as unsatisfiable. Satisfiable, that is same as tautology or contingency. All these points we have seen. Contingency means at least one time true and at least one time false. This is your contingency. At least one time false, that is falsifiable. Yes or no? At least one time false, that is falsifiable. Contingency means neither tautology nor contradiction. These are the definitions. Please tell me, all the definitions, are they clear? Let me know. Okay, you can read this. You can see if these are Boolean variables, then what is A? If A comma B are Boolean variables, if they are propositional variables, then A is contingency. Yes or no? Because A will be either true or false. A will be true or A will be false. So you can see that if A comma B, if they are propositional variable, then A is a contingency. A implies B, that is also contingency. A or negation A, that is tautology. A and negation A, that is a contradiction. Fallacy means contradiction. Okay. And you can see A implies B implies A. You can check this is tautology. You can create the truth table and you can see this is always true. A implies B implies A. This is always true. So this is tautology. Okay, very simple. Every concept is very simple. Now let's move on. Let's see this GATE 1988 question. Define the validity of a well-formed formula. First of all, you tell me what is well-formed formula. Do you know? Do you know what is well-formed formula? WFF. That is same as propositional formula. That is same as propositional formula. Or you can call it propositional expression. Or you can call it propositional expression. Or you can call it compound proposition. These are different names for the same concept. Okay. So well-formed formula, that means propositional formula, or I can say propositional expression. Now tell me, when can you say a propositional formula is valid? Valid. When can I say a propositional formula is valid? Valid means always true. Valid means always true. So finally, I can say that a well-formed formula. Okay, so this is the final point. So I can say final point is that a well-formed formula H is valid. When can I say a well-formed formula? That means propositional formula. A propositional formula H is valid. When can I say H is valid? If and only if H is always true. H is always true for every truth value combination of its variables, for every row in the truth table. H is always true for every row in the truth table. H is always true for every truth value combination of its propositional variables. So remember, a formula H is valid if it is always true. Okay, validity means always true. So this is GATE 1988 question. Okay, so you can see this table. In this table, you can see valid means tautology. Tautology means always true. These things are same. You can see this is tautology. Tautology means always true. Always true, that is same as valid. You can see this table. This is a beautiful table. Okay. So thank you everyone. This is enough for this session. We will continue in the next session, and in the next session we will complete this propositional logic complete summary. Okay. So there are few things that are remaining. Those we will see in the part 2. Propositional logic complete summary part 2. In that we will finish the propositional logic summary. Okay. So thank you everyone. Please like and comment. Please share your feedback in the comments. Let us know these summary lectures, are these useful, are these helpful? So let us know in the comments. Okay. Thank you everyone.